All right, and welcome to the Android Application Development course for beginners. So I'm going to assist you throughout this course. So if you're ready, let's get started right away. All right, so first off, I do want to explain who should be taking this course. This course is an absolute beginner's class, and that means that you don't have to know anything about Android programming, or for that matter, Kotlin programming language. Yeah, so you're going to learn everything about Android development. Even if you don't know how to write code, it's going to be okay. You'll also learn how to write code and programming concepts together. Yeah, so this course is designed to teach you how to think like a programmer, how to write code, and how to build an application and everything. We used to say, or my grandma used to say, from soup to nuts, right? So, if you do happen to know something about coding, you can still take this course because you're going to be able to learn about everything in this Android app development process. For example, if you know C# programming or Java programming, this is going to be great for you because you can use your programming experience to develop really good applications. You can combine what you have known and learned before with what you're going to learn in this course. If you want to be an Android developer, you should take this course because you're going to learn how to become a superb Android developer, how to design an Android application, and how to build a good and in-demand application. Now, you're probably thinking, yeah, okay, what am I going to really learn in this course? Well, first of all, you're going to learn Kotlin programming language. So we will use the Kotlin language to build Android applications throughout. There are two popular programming languages in order to build Android applications. You know what they are? Java programming and Kotlin. All right? So why are we going to use Kotlin? Well, I'll tell you, that's a very good question you ask. See, because Kotlin is a very new and up-to-date programming language. Kotlin is accepted by Google as the official language for Android development. Therefore, it is a language that everyone who wants to be an Android developer ought to know. So in this course, we're going to teach Kotlin programming language from the very beginning concepts right the way through to the advanced level. All the while considering the importance of Kotlin. This is an absolute must-know. If you don't know about Kotlin programming, like I said before, it's okay because you're going to learn it throughout this course, bit by bit, step by step. You will learn basic information about Kotlin and all of the programming concepts throughout this course. Now, if you know Kotlin programming language from before, you might be able to skip this first part and start the Android application development chapter. But you never know what you're going to pick up. I always like to begin with beginner's mind. So after you learn Kotlin programming language, we'll start to learn Android Studio front to back. Android Studio happens to be the official integrated development environment, or IDE, for Android application development, right? We're going to learn the Android Studio platform and its working system. Then you will learn the Android ecosystem. So Android is an operating system like Windows, but for mobile devices. And its popularity is increasing day by day. It doesn't only use phones anymore either. It uses tablets and smartwatches and smart televisions. With the increasing use of Android operating system, well, the need for new Android applications is increasing as well. The need for new Android applications is going through the roof. So for all these reasons, the need for Android application developers is also increasing. All right, so after recognizing the Android ecosystem, you're going to learn Android components. Now, Android application components are the essential building blocks of an Android application. You'll learn how to build an Android application in these chapters. You will also see every Android component required for building a perfect Android application. You're going to develop 2 Android applications throughout this course. You will learn from scratch how to build an Android application. And also, you're going to publish your app on Google Play. You will learn how to open the Android developer account and how to publish your app. Now, if you do happen to come up with a question that you just can't seem to find the answer for while you're watching this course, well, you can always send us your question from this Q&A section below the course videos. You can also share the sections or codes that you think need to be corrected, maybe updated, and we'll tell you why you're wrong. Nah, I'm just playing. I want to thank you very much for being in touch. But we promise you that we will make the necessary updates as soon as we can. What does that mean? Well, you're always going to have the most up-to-date information and content. So I think you're ready. Why don't we just begin the course? I'll see you throughout. Well, hello to everybody. So we're going to talk a little bit about this Android ecosystem for this video. So we'll start without wasting any more time because we got to get to it. We got a lot of good stuff to do. All right, be quiet and tell me. You betcha. Android is an operating system designed for use on mobile devices. The Android operating system was originally created for use in digital cameras. Bet you didn't know that, did you? So the Android operating system is developed primarily for use now on smartphones and touch tablets by Android and Google. Google bought the Android company in 2005, and the Android operating system was released in 2008. Although Android is developed for smartphones and tablets, today it's still being used in Android television, smartwatches, Android Auto, and Android Wear devices. Android Auto is the car smart multimedia system, in case you weren't aware. So, Android operating system is used in more than 100 languages today. That's 5.22 billion people who are using a mobile phone today, and that equates to 66.6% of the world's total population. Also, more than 2 billion people use the Android operating system as of May 2017. Google Play has more than 2.8 million applications published, and more than 6,000 applications are published on Google Play every day. More than 20 million application developers will be needed in the next few years. Yeah, I'm looking at you, right? So this means that you need to learn this Android application development really, well, I'd say kind of quickly, but thoroughly, but quickly. So I believe this course is going to be really good for your process, okay? So after this course, you will be a very good Android application developer. All right, well, at least a good one. Anyway, let's get going. So another motivation factor, let's talk a little bit about salary. I know you wonder how much your salary is going to be. Well, I'll let you in on a little thing here. Junior Android developer salaries are more than $55,000 per year in the U.S., but I believe you're going to make more. Middle-level Android developer salaries, more than $100,000. Senior-level Android developer salaries is about $130,000 US dollars per annum, as they say. So this chapter was just to give you some, general information about the Android ecosystem. Hope it was useful. After this video, we're going to start to install Android Studio. If you're ready, let's go. All right, friends, glad to have you back. So on this lesson, we're going to prepare our computer to write code in order to develop Android applications using the Kotlin programming language. Now for this, we will first install the JDK or Java Development Kit. Now earlier, remember we said that this Kotlin language runs on the Java virtual machine. So therefore, in order to develop applications using Kotlin, we will need to install JDK onto our computer. Now, before we move on to the JDK installation, I would like to briefly explain the concepts of a Java Development Kit that we refer to as JDK, a Java Virtual Machine, or JVM, and Java Runtime Environment, or JRE. So this Java Development Kit It's a software development environment, all right, and it's used to develop Java applications. But this package contains all the tools that you need to develop with Java. If you want to develop and run applications, you will need to install JDK onto your machine. It actually includes Java Runtime Environment and other developmental tools. Development tools are things like compilers, Java debuggers, and other things that you'll learn. The JRE, or Java Runtime Environment. This is a software package that combines libraries, the Java virtual machine, and other components to run applications written in Java. Right? So the JRE is the runtime portion of Java, and this is all you need to run it in your web browser. It includes Java Virtual Machine, or JVM, and libraries. So the Java Virtual Machine is a virtual machine that runs Java programs. So when we run the Java program, the Java compiler first compiles your Java code to bytecode. And you get this bytecode by compiling the .java files into .class files. .class files contain bytecode understood by the JVM. So in short, if you are a Java or Kotlin programmer, you will need the JDK to develop and run applications. And this package will also include the JRE and the JVM. Yeah, so there you go. That's a brief little overview about the JDK. So we'll move on to JDK installation. So first up, you just have to open your browser, and here I'm using Google Chrome, but I think you can use any browser you want. Let's get too extreme here. Anyway, now let's write download JDK in the search bar. So after pressing the Enter key, I'll just open the first of the results, namely the Java Standard Edition, or SE, Downloads Oracle Technology Network page. So if you notice, the most up-to-date version of Java is Java 16. Now, if you do see another version here, don't worry about it. The JDK installation is the same in all versions. So you can successfully complete the JDK installation just by following the next steps. So I'll click on JDK download, and that's the link in the Oracle JDK section here. So this page that opens, this is the Oracle JDK page. I want you to notice there's an important warning text here, okay? Oracle JDK changed its license April 16, 2019. So in other words, while personal and development JDKs were free, those used for commercial purposes have become paid. So for that reason, Oracle offers us the Open JDK version, which is open source. So that's why I'm just clicking on the jdk.java.net link here. So from this page it opens, I'll choose JDK 16, which is the most up-to-date and ready-to-use version. Now from this page it opens, we can download the appropriate JDK for our computer. And as you can see, there are JDK installation files for Linux and Mac and Windows. Now my computer is operating with Windows 64-bit, so that's why I choose the zip option from here. And you can see that my download has started. I hope yours has too. So of course, depending on your internet speed, it could take some time to download. So I am just going to stop screen recording here, and then I'll come back when the download is complete, and we'll just continue where we left off. Happy downloading. All right, my friends, so my download is complete, so I'll continue by clicking on the arrow icon right here and select Show in Folder. All right, so now I'll need to extract this file here. Now, of course, you have to have a compression or decompression program on your computer to be able to do this. If not, you can always download it from the link that I've added right into the resources of this lesson. So now I'll just right-click on the zip file and select Extract here. Right, so as you can see, we've obtained a JDK folder. And now we will move the JDK folder to the Java folder that we will create in the Program Files folder. So for this, I just cut JDK folder by pressing Control X on the keyboard. And let's open up Program Files by selecting this PC and local disk C. And now let's create a folder called Java here. So I'll right-click with my mouse, select New, Folder. I'll just name this file Java. So now I'm pasting the JDK folder that you saw me download earlier. All right, so we have now installed the JDK on the computer, but we do have one last step to do. We need to define the path of the java.exe file in the JDK folder here to the operating system. So for this, I can just open up JDK folder, and I also open up the bin folder. All right, so let's find the Java file here. All right, so I found the Java file. Now let's define the path of this file to the system. All right, so first I just click on the address bar at the top of the window and copy the file path here by pressing Control-C right here on the keyboard. Now let's define this file path to the system. So I'll right-click on this PC from the left side and select the Properties option from the drop-down menu. And from this window that opens, well, you can learn some of the basic information about your operating system, should you need to. So now I'll select the Advanced System Settings option right on the right. I'll select the Environment Variables option from the System Properties window that opens. Now, if you notice, there are two different sections here. We're going to use the bottom section, namely System Variables, to define the JDK to the system. So that means after selecting the path option from the section here, I choose the Edit option. And here we'll just paste the path to the Java file in the bin folder. So to do that, I'll select the New option and paste the file path we just copied by pressing the Control and V keys together on the keyboard in this field that opens. All right, so that way we have now defined the JDK file to the system. So the meaning of this process is just like this. If you want the operating system to run Java, the operating system has to know where the Java exe file is. Otherwise, it's not going to be able to run it, okay? So for this reason, we have defined the folder where the java.exe file is located on our operating system. And finally, I can press the OK button. So I press OK once again. And there you have it, my friends. You've just watched me complete the JDK installation necessary to develop applications using Kotlin. I hope you did it along with me. If not, catch up and install it, because we're just going to take a short break here. And in our next lesson, we're going to install the Integrated Development Environment, or IDE, for Android Studio. And this, of course, will be necessary to develop Android applications. All right? See you in the next lesson. All right, hello friends. So in this lesson, we will download the IDE that we will use to develop Android mobile applications, which is also called Android Studio. So now we'll do the necessary installation procedures. Android Studio is a completely free platform. It can be downloaded and used by anyone, but then you have to learn how to use it, huh? Now, I also want to explain a little bit that IDE is a software application that combines all of the features and tools needed by a software developer. So a developer would be able to debug, run, and test applications with IDE. And because it provides useful debugging and testing features, it's all in one handy place. So IDE helps us in quickly navigating to a type without really needing to worry about our project. It also provides auto-completion. That means you start typing a part of a function or a class name and press a shortcut combination, then the rest of the name will be automatically typed in for you. I love it. Now, all these features are pretty good reasons for you to prefer an IDE. But I'll tell you something for nothing. The most used IDEs for Kotlin are Android Studio and IntelliJ. I prefer Android Studio, so I'm going to introduce Android Studio to you, and I'm going to write Kotlin programs on Android Studio during this course. All right, how's that? So, if you want to continue with me, let's do these necessary steps to download Android Studio now. All right, so first up, we need to open our browser. So in the search bar, we just write Android Studio Download. Press Enter. And here we will open the second result, namely Download Android Studio and SDK Tools. Now, if you pay close attention, the site is the developer.android.com site, right? So this site is a site that Android developers must follow, my friends. So you can follow the latest developments, updates, and documentation required so that you too can develop applications on and for Android here. All right, so we can now proceed with the download. So this looks like the most up-to-date version of our Android Studio. Now, of course, I do want to point out something here. Android Studio is continually updating. So even while I was creating this video, the most current version is 2020.3.1. So this version is called Arctic Fox, right? So this version might appear different to you. But pretty much the download and installation process of Android Studio is the same. So it just won't make a difference. But if you do see a different version here, I just don't want you to worry. All right, so just by following these steps, I'm going to explain how you can perform the download and installation process, and then we'll get going, okay? Now, before proceeding with the installation process, I would like to show you these Android Studio system requirements. Now, at the end of the page is the system requirements section. So just review the section. You can find out whether the computer you're using is sufficient enough for Android Studio. Just a little disclaimer here. If your computer does not meet these specifications here, you could, well, buy a new computer. Or you can just change some of your computer's features, right? For instance, if your computer is 4 gigs RAM, you could increase it to 8 gigs relatively simply and inexpensively. You could even drop back a version or two of Android Studio, but, you know, I would pretty much recommend you to just move forward. Whatever it takes, right? But anyway, let's just now download Android Studio. So I'll open up the top of the page, and if your computer's operating system just happens to be Windows 64-bit, it'll pretty much look like mine, and you can start the download process just by clicking the Download Android Studio button here. If your computer's operating system doesn't happen to be Windows 64-bit, well, you can click on the Download Options tab on the left. So when you click on that tab, see the download links for 64-bit, Mac 64-bit, Linux 64-bit. But yeah, you probably noticed there's no option for 32-bit operating systems. So it's time for you to get into the 21st century if you need that. I'll tell you why. Because Android Studio doesn't support 32-bit at all since version 4.0. So if your operating system is 32-bit, well, just go ahead and download Android Studio 3.6.3. All right? So this is the last version of Android Studio before 4.0. No shame in it, my friends. This is how we learn, right? Anyway, for this, we could click on the Download Archives link. And then from the window that opens up, we just need to accept the relevant contract terms. So for this, I could click the Agree with Terms button. And as you can see, we have accessed all of the versions of Android Studio. So we're a pretty versatile bunch, huh? So from here, you can find the 3.6.3 version of Android Studio and use a download link required for 32-bit operating systems. So whichever version you want, let's start the download process. So, of course, I'm going to open up the previous page since my computer's operating system is Windows 64-bit. That means I will download the appropriate Android Studio. But no matter which page you're on, just click on the file with the extension .exe here. And in order to download the Android Studio, we will need to accept the terms of the contract. After confirming the checkbox here, the button that we will use to download Android Studio becomes active. So clicking this button will start the download process. So I'll just click the button. And yeah, so here you can see that the download has started. And yes, just like before, the download process may take a little bit depending on your internet speed. So I'm just going to fast forward through this. Wow, that was fast. And now you can see that the download is complete. So I'll click on the arrow button, well, it's really an icon, to the right of the downloaded file and select the Show in Folder option. So here we can view the file that we've downloaded. So I'm just going to double click on this. Windows asks, do you allow this application to make changes to the computer? Yeah, that's quite a warning. I'm just going to press yes. So the warning might not appear for you. It's not really important. But whatever you have to do to install, you'll install, because here you can see the installation screen opens. And here we click on Next. And once again, we press Next. Right, so the location where the files will be saved will be written to. So you can change this location, or you can just keep it wherever it is by default. I usually prefer, actually, the default file path. That's why I just press the Next button once again without making any changes. That way, if it knows, I know. So here it asks if we can create a shortcut for Android Studio. Now, in fact, it's reading my mind because I do want to create a shortcut. You don't have to if you don't want to, but just confirm the checkbox here. So I'm not going to make any changes. So now we can start the installation process. By clicking the Install button here, we will start the installation. And as you can see, the installation process begins. And just like downloading, this process may take some time, so I'll just fast forward. And yeah, that was a great installation. And now it's complete, so I'll press Next. So it states that the installation process of Android Studio is now complete. Yay. So if we want Android Studio to start after the installation process, we just need to check this checkbox. I'm going to uncheck it, though. And we're going to start Android Studio together. So please do that, and I'll press Finish. All right, so that completes the necessary installation process of all these things. So, in fact, you could call this the pre-installation of Android Studio, because we haven't quite completed the installation of Android Studio yet. We still need to install the SDK. That we're going to do in the next lesson. So we'll take a short break here, and I want to see you there. All right, hello, my friends. Now, in our previous lesson, we completed the installation of Android Studio, so you know what that means. In this lesson, we will examine the interface of Android Studio. All right, so let's get right to it. So, of course, after creating our first project, we encountered a screen like this. So then at this point, I would like to remind you once again, after making sure that your project is fully loaded in the Build section, you must perform the necessary actions. See, because if your project has not been loaded yet, you can wait for the project to load completely without taking any action. All right, so after making that little disclaimer reminder, we can now examine the interface of Android Studio. All right, so if you have a look, we can actually break down this interface into 4 different parts. So the first part is, well, this is the part where we're going to do the coding and the necessary designs for our projects. Now, if you notice, there are two tabs here. First of these is a main activity, and this is what we're going to use when we write code. And the second one is the XML file that we can design for our project. Now, while developing an Android application, we first create the design of the application that we're going to make, and then we can write all the necessary coding for this design. So, in fact, this section is what we will use as the very basis of what we're going to do from here on out. So for now, it's enough to know that this is where we start. So after examining the other parts of the interface, we're going to examine this part in detail. So in other words, we'll come back to it. Now, the section here on the left is the section where the project files are located. So if you see this part differently, you can just click on the part that says Android above. So here on your screen, it might say project instead of Android. Okay, so you can choose the Android option from the pop-up that opens, and here's a little menu, and let me just talk about this a little bit. So when we create a project in Android Studio will also create many different files related to our project for us, just automatically. So that way we have the opportunity to run our project on different platforms, share it with different people, or even publish our project. So this feature is the main reason why we use IDEs like Android Studio instead of a simple text editor when coding. So if the project is selected instead of Android here, we will view all the created project files in here. Of course, this kind of creates a complex view because while developing applications, we're not actually going to be using every file that is automatically created. Therefore, for a simpler view, just make sure that the Android option is selected here. So if we examine the project directory here, a new folder has been created under a Java folder with the package name that we specified when creating the project. And just below the package folder, the Kotlin class, that is main activity, where we will do the coding, right, has been created as well. So when we develop an app, we will make our applications where we will need more than one class, yeah? So here are the Kotlin classes that we will create for this stage. Now, you may not know the concept of each of the classes right now, but don't worry. We will learn these terms in detail throughout our upcoming lessons. Now, we also talked about the design file. So where is this design file, you might ask? Well, if you look a little further down the project directory, you will see a folder named Res has been created. And this is actually the resources folder. Maybe I should call it Reese. But then I think of peanut butter cups. Okay, so this is the folder, in any event, where the design files, images, colors, writing styles, and themes related to our project are kept. So we're going to dig into these in detail too in the future. I want you to also have a look in the layout folder here. There's the design file of our application. So now if you close the main activity class and the activity main.xml file right there next to them by pressing the X sign, you can open them up again from the project directory. So we can also collapse and expand the part reserved for the project directory. For this, you can position your mouse on the line between project panel and main panel. Now notice that the cursor has changed, right? So you can expand or collapse the project panel by dragging it to the right or the left. You can also close and open your project panel completely. For that, you just press the minimize icon here. If you want to open the project panel again, you can just click on the project tab here. All right, my friend, so that's pretty much the project panel. So now we can look at the menu bar at the top of the interface. So here you can see many windows and many interfaces. From the File tab to the Help tab, Okay, so first we can examine the File tab. As you can see, there are many features in here, but we will examine the features that we will use just, for the outset. During the course, we will, of course, examine the other features as we need them. So first off, you can create a new project by using the New and New Project options here. By using the Open option, you can open up a project that you have created before. You can also close your open project by just using the Close Project option. You can use the Settings option here to make the necessary settings for Android Studio. Of course, some of our friends will be using the Macintosh OS, so we can, or you can, anyway, click on the Android Studio icon that's just to the left of the File tab and select Preferences from the pop-up menu that opens there. All right, so now let's go ahead and open up the Settings screen. Now you can search for the feature that you want to, because there's a very clever search bar here. For example, size of text in the area where we will be coding can be quite small. So I'll just enlarge it text so that you can see it better. All right, so for this, I just type font in the search bar. And as you can see, when you type font, the relevant features become available. So in order to change the necessary features, I'll first delete the text font from the search bar. Thus, the relevant fields become active. So now you can change the font from the font section here. You can also enlarge the size of text from the size section just below. So I'm going to set the font size to 18. Press OK or Apply at the bottom right. And that applies the changes. So as you can see, the text can be more readable now. Of course, you don't have to make it that big. I'm just doing it in a way so that you can see it easier. But now I want to look at another feature. I'll go back to the search bar and type in theme. All right, so using this feature, you can change the interface theme to dark mode or light mode, depending on your preference. All right, so let's examine the SDK section and finish the settings. So I'm writing SDK into the search bar. Here you can see SDK, and there are also 3 tabs just below. So the first is SDK Platforms. If there were any problems during the installation, we could download the SDK that we need from here. As you can see, here's the installed statement. If you happen to have an other statement, you should tick the checkbox here and press the Apply button. And that way you just reinstall SDK. Just installs what's necessary. So I open up the second tab, SDK Tools. As you can see, there are 4 tools installed here. If you're missing any of these, if it's not installed or if it needs to be updated, just go ahead and tick this checkbox here and press the Apply button. Now, of course, some of our friends are going to be using AMD processors, so you will need to select the Android emulator hypervisor driver for AMD processors. Such an option that you can check here. Now, I actually should mention that we are going to test the different applications that we develop on virtual devices that Android offers to us. These are typically called emulators, right? So these emulators use virtualization technology. Therefore, virtualization technology must be active on your computer. Otherwise, you wouldn't be able to install the emulator. Now, I shared the steps that you need to do to activate the virtualization feature of your computer as an information note in our next lessons, but I just want to give you a heads up. This feature is usually active on computers that already have an Intel processor. Okay, but computers with AMD processors, we might have to change it manually. So just keep that in mind. So yeah, let's continue. We can also install Google Play services and USB driver tools here. That way, if you want to test your projects on your Android device instead of on an emulator, You can always install these tools. So for this, I'll just tick the checkbox and click on Apply. Click OK. And accept the necessary licensing agreements. So when you click the Next button, the necessary installation process begins. And of course, my friends, if you encounter any errors during the installation process, if the necessary tools are not properly installed, well, you can just go back to the Settings section and complete your installation. All right, so now that the download process is over, I'll just press the Finish button. And sure enough, my friends, that completes this edition of the Settings Show. Now let's have a look at some of these other tabs that we're going to use. So I want to show you the View tab. So by using this tab, you can toggle many views in the interface. For example, by using the Tool Window tab here, we can open and close the tools on the edges of the interface. And again, from the Appearance section here, you can choose which tools that you want to appear on the interface. For example, if we select the toolbar from here, the Save the Project, Open an Existing Project, or Reload the Project icons will appear on the interface. The View tab is, well, generally like this, so I don't think I have to do anything more here, because we're actually not going to use these other tabs here much, but, you never know. So you can open those and close those in your own time. But I just wanted to let you know where they are. So finally, though, I do want to show you the Build tab here, because sometimes after the project is created, well, you might get an error or two. So in that case, you may need to rebuild your project. So to rebuild the project, you can just use the Rebuild Project tab here, and it'll allow you to rebuild your project. There may be some other situations where you need to restart your project, so you can always restart the project by selecting the Invalidate Caches and Restart, which is the option here under the File tab. And but don't worry, I'm going to explain this section in the tutorial where we will install the emulator, all right? So don't get too carried away. So why don't we go ahead and examine a little bit of the design area. So for this, I want to open the activity main.xml file. If you want to, we can close the project panel and you can see it more easily. All right, so that looks better. So we're only looking at the design space now, right? So we can get the design space a little closer, a little bit broader, a little bit fuller. And we can examine this design area by breaking it down into 4 different sections. The first is this palette section, upper left, okay? Here are the components that we're going to use while we're designing. For example, we'll access many components from here, such as buttons, text views that we can write text into, and image view components that we can add images to. And of course, we'll be using them, and I'll be showing you some of the details in the following lessons. So this is just a brief overview with some general info. So we can actually move any of the components here to the design area just by dragging and dropping. Also, if you click on the eye icon here and select the Show System UI option, you'll get a real Android phone screen. So you can make your designs that much better. There are also a couple of views in the design area. We don't really use the blue area. We'll only be doing our designing in the white area. So in order to edit this, I can click on the Select Design Surface icon here. And then when you select Design from here, only the white design area appears. And if you select the Blueprint option, only the blue design area will appear. And then if you select both sections will appear in the design area. But since we are doing our designs using just the white area, I will just choose the design option here. All right, so I'm going to delete the text view component where the hello world text is written. This you can click on the component and press the delete key on your keyboard. Now, if you press Control and Z, you can always undo your actions. Or after selecting the component, you can just right-click with the mouse and select the delete option. So I couldn't exactly select the component. Did you see that? So I'll zoom in on the area and select it. Yeah, okay, see. Got to be a little closer sometimes. So finally, you can select and delete the component from the component tree section, which is the second part of the design area. That was a smooth segue, huh? So again, to add components to the design area, you can just drag and drop the component that you choose from the palette section to the component tree section. Now, the component tree is where the components that we use in the design area are located for your design use. And we can select the components from the design area. We can also select them from the component tree, change their required properties. We can also change the properties of the components from the attribute section located on the far right. Now, to change any feature of a component, for example, the text size or the color, after selecting the component from the design area or the component tree, we can find the feature that we want right here from the attribute section and make any changes that we want to. And of course, we'll be doing all of these processes in detail later on, but now you know where they're located. So I do want to tell you this, though. If you notice, the design file is actually a .xml file. So in other words, an XML code is actually created for all the components that we'll be using while designing. And here are all the properties of the components as well. For example, to add a button to the design area, we can add the button from the palette by dragging and dropping, or we could create it by writing the XML code. And for that, we can just open the split or code tabs on the upper right corner. And if we open the code tab, we will only see the section where the XML codes are written. So if we open the split section, we can see both XML and design. So if you open up the design tab, you can only see the design area. And then if you notice, the XML codes for the button that we created are automatically generated. Cool. So in our next lessons, we will learn how to create the components using XML. But my friends, you can see Android Studio's interface is pretty easy and fun to navigate around. I've shown you most of the parts that we're going to be using frequently throughout this course, so we will get into the details in the future. All right, my friends, so we've made all the necessary preparations to develop our applications using Kotlin. So now we can just, well, now that we're all set up, we can just focus on learning the Kotlin programming language. So the way that's going to go is teach you Kotlin, then we'll develop Android applications using Kotlin. So therefore, I will install the emulator after we hit up some of this Kotlin language, okay? So we'll take a short break here, and I'll see you in the next video. Hello, everyone. So in this lesson, we are starting the main fundamentals of this Kotlin programming language, which is why you signed up, right? So one of them is variables. So in this section, we're going to first learn what is a variable, but then we're going to learn how to declare and initialize variables. You see, that way we'll be learning types of variables because there are mutable variables and immutable variables, and everything's variable, all right? So let's start off with this variable question. So if you think of variables like a container or a box, which holds a value for you during the life of your particular Kotlin program, right? So we'll keep it relevant. So what it means is once you create a variable, you can reserve some space in memory. So every variable is assigned a data type, and then it holds the quantity of value or whatever the heck you're putting in there. I'll show you why I say that. Because there are two different steps to use a variable in a program. All right? Declaration and initialization. So in order to declare a variable, you must specify the variable and give a unique name to the variable. So in our example, we'll declare the variable to be age. Now, in order to initialize a variable, you've got to assign it a valid value according to its data type. So we use the equal sign, means that the value on the right side of the equal sign will be saved into the variable on the left side. Follow? So in our example, we assign the value 37 to the variable age. All right, cool. So I want to tell you, though, that this Kotlin programming language has rules and conventions for naming variables. So while declaring variables, please note that Kotlin is a case-sensitive programming language. That means that upper or lowercase letters in your Kotlin programs matter. They matter a whole lot. So this variable age that here consists of all lowercase letters is way different from a variable age, which would be the first letter capital and the rest lowercase. So to continue with these naming conventions and rules, a variable name can begin with a letter or an underline mark. If you declare a one-word variable name, use lowercase all letters. This isn't necessarily mandatory, but it is conventional wisdom. Also, if you declare a variable name having more than one word, use all lowercase letters for the first word and capitalize the first letter of the next word. All right? So now let's get into the types of variables. So we have two different types of variables in Kotlin. Mutable variables are represented by var. Immutable variables are represented as val. So basically, val and var are both used to declare a variable, but var is like a general variable and can be assigned multiple times. This is also known as the mutable variable in Kotlin, whereas val is a constant variable. How's that? And cannot be assigned multiple times and can be initialized only one single time. So that's why this is known as the immutable variable in Kotlin. All right? Val, the immutable variable in Kotlin. Sounds like a hero. But we're not doing a complex game right now, so we'll postpone that idea. All right, so enough about variables. Why don't we just move on to Android Studio and do a little bit of an exercise? This way you'll get used to everything about it. So first, we'll create a new Kotlin file. For this, all I have to do is right-click on the package folder in the project directory and select New Kotlin File, and follow the options. So I'm specifying the name of this file to be variables. So when you press Enter on the keyboard, the Kotlin file is created. Now remember, we needed at least one main method in Kotlin. So first, let's create the main method. But this time I want to show you how to create the main method in an easier way. All right, so I'll just type in main here. From here, I'll select the main A option and press Enter. And what do you see here? We created the main method right away. All right, so now we can get to coding. All right, so we'll declare three variables. First, I'll write var A and assign a value of 10. Second, B and assign a value of 20. And lastly, C and assign A plus B. Okay, so let's print variable C on the screen just by using the print method. Now, Android Studio has a quick shortcut for you to write this method, so just type sout and then hit Enter on the keyboard. So this is named code completion. So it allows us to quickly complete statements in our code. We can use this combination in, well, all of the other parts of this program: variables, functions, classes, etc. Also, notice that in our previous lesson, we used only the print function when printing hello world to the console. But here we're using the println function. So this means that after we print the desired expression to the console, the cursor then automatically moves to the next line. That is, when we print more than one result to the console using the println method, the results are listed one below the other. All right, very cool. Okay, so let's run the code. For this, right-click on the variable Kotlin file and select Run. And the result will print 30 in the console. Also, we can directly write A plus B to the output. Okay, so let's run it again. And the result is correct. Very good. So let's look at some of the naming rules for variables. So we're going to study this via variable age. Var age is valid. So also, I would like to mention the comment line in Kotlin here. So in this Kotlin programming language, if you use a double slash, all the statements you type from that point on through to the end of the line are perceived to be comments. That is, it's not perceived as code. Comment lines are not taken into account when compiling your code, right? If you want to use more than one line as a comment line, well, you can write whatever you want between /* and // this time. So just by using this feature, you can take notes on the margins of code here. All right, let's continue from where we left off. Var _ age is valid. Var age 3 is valid. But var a space GE is invalid, right? And 3 age is invalid. All right, because a variable name cannot contain a space, as well as you can't begin a variable name beginning with a number. All right, so let's comment out our code here. So I'll use the slash and asterisk marks for the comment line, as there are multiple lines. All right, cool. So now I want to show you the difference between var and val. So first off, I'll create a variable of type var named age and assign the value 20. All right. So now I'll assign the value 10 to the age variable in the next line. And now let's print the age variable to the console. So what do you think is going to be written on the console? You must have an idea, right? 10 or 20? Cool. So those who said 10, you got it. Because the type of the age variable is var. And we can change the value of this variable, type var. We first transferred the value 20 to the age variable. Then we transfer the value 10 in the next line. And as a result, the value of the age variable became 10. And we printed 10 to the console. So now let's create a variable of the type val. So I'm typing val year, and I'll assign the value 2020 to the year. So let's try to change the value of the year variable in the next line. So I will write year equals 2019. Yeah, so as you can see, Android Studio throws an error because when we position the cursor over the word year, we see the warning, val cannot be reassigned. All right, so in other words, we wouldn't be able to pass a second variable to a variable of the type val. All right, so what's going on here? When do we need the val and when do we need the var? Well, while developing an application, we may want the value of some variables to remain the same. For example, if you're going to make a calculator and you're going to use the value pi, and you're going to specify pi to be 3 all over this application, well, in this case, you could create a variable of the type val named pi. All right. Or we could think of it like this. Let's say you've developed an application that retrieves some data from the internet. So in this case, the data retrieved from the internet may vary from time to time. So in that case, you would definitely specify the type of the variable that you would define to be var. All right, so that's the concept of var and val. I hope you understood them, because now you really just need to play with them and write them in and see how you do. But now you know what you need to do in order to create a variable. All right, so in our next lesson, we're going to learn about data types. So I'm going to see you there in the next video. All right, well, hello, my friends. So in this lesson, we're going to go over some data types. The data type basically defines the values that a variable can take. Based on the data type of a variable, the operating system allocates memory and then decides what can be stored in the reserved memory. So therefore, by assigning different data types to variables, you could store integers, decimals, or characters as these variables. So in Kotlin, we generally define the data type of the variable to use it, and we cannot assign incompatible data types. Otherwise, the compiler will give us an error. So let's have a look at this diagram. Now, there are 5 basic data types available in Kotlin. First one is Boolean data types. The second is character data types. And this is represented in Kotlin as char. Now, the third is a numbers data type, and there are 2 different number variables. So the first is integer variables, and the second one is floating point variables. There are 4 different integer variables, and these are byte, short, int, and long variables from smallest to largest. Floating point variables are also divided into 2. These are float and double. And then finally, we'll get to string variables, and these represent textual expressions in arrays, and these can hold more than one value in themselves. All right, so let's have a look at the different Kotlin data types in this table. The byte data type is an 8-bit signed 2's complement integer. The byte data type is useful for saving memory in large arrays. It has a minimum value of -128 and a maximum value of 127 inclusive. So the default value of the byte is 0. The short data type is a 16-bit signed 2's complement integer. Similar to byte, uses short to save memory in large arrays in situations where the memory savings actually matters. Now, this has a minimum value of -32,768 and a maximum value of 32,767 inclusive. Also, the default value of short is 0. The int data type is a 32-bit signed 2's complement integer, which has a minimum value of -2 to the 31st and a maximum value of 2 to the 31st minus 1. The long data type is a 64-bit 2's complement integer. The sign long has a minimum value of -2 to the 63rd and a maximum value of 2 to the 63rd minus 1. So you use this data type when you need a range of values wider than those provided by int. Float data type is a single precision 32-bit floating point. So if you need to save memory in large arrays of floating point numbers, definitely use a float instead of a double. The double data type is a double precision 64-bit floating point. For decimal values, this data type is generally the default choice. Boolean data type will represent only one bit of information, either true or false. The char data type is a single 16-bit Unicode character. All right, so when defining data types in Kotlin, we've got to first specify the variable type. Then we write the name of the variable that you're going to create. So in this example, the name of the variable is age. Then we have to specify the data type after putting in a colon. So in this example, the data type is integer. Yeah? Okay. So after the equal sign, we've got to pass the value of the variable. So in this example, I have passed the value 20 to the age variable of the type integer. Okay? So that's how we define a variable in Kotlin. All right, so that's marvelous information that hopefully you didn't know before about using variables with Kotlin. So we'll move on to Android Studio and do a little bit of an exercise. Cool, so we first got to create a new Kotlin file. So I'll just right-click on the package folder in the project directory and select New Kotlin File. Now, I'm specifying the name of this file as data types. So when you press enter on the keyboard, our Kotlin file is created, okay? So of course you remember that we need at least one main method in Kotlin. First, let's create the main method. So we'll start with data types, var Boolean equals true. So this Boolean type has two possible values, either true or false, yeah. Var char equals R. Char type declares a character. Var byte equals 12. So this byte type can have values, right, between minus 128 right the way through 127. Var short equals minus 356. So the short type can have values from negative 32,767 right the way through 32,767. Var int equals 43,543. Int type is generally used for numeric values. So now let's declare variable f with the long data type. The long type is used for large values, as I'm sure you're remembering. So this capital L is a specific suffix for the long type. Another variable g with float data type, and float type is used for large values with single precision. And capital F is the specific suffix for float type. Now another variable h with double data type. So double data type is used for large values with double precision. So there we go. We've defined the variables. We've set their initial values. So now let's print the values of these variables on the console just by using the println function. So first I will print the a variable to the console. Now I'll copy this line of code by pressing Ctrl-C on the keyboard at the same time, paste it 7 times by pressing Ctrl and V on the keyboard at the same time. And let's change the variable name from A to H. All right, so now let's run the code. Let's see the results in the console. Very cool, my friends. So we're going to end this lesson here, and next time we meet, we will learn type conversion and type casting. All right, so I'll see you in the next video. All right, hello, my friends. So in our previous lesson, we learned the data types that are used in Kotlin. But we haven't learned any string and array data types yet. Well, We're going to learn more about this data type in our next lessons. But in this lesson, we got to first learn how to convert between data types. Wait, what? Why would we need to convert data types? Why do we need data conversion? Okay, before you ask too many questions, let's say that you're going to develop a calculator application, and you'll divide the one integer number entered by the user by another integer number entered by the user. But the result of the operation may not always be an integer. So in this case, if you don't convert the result to a double or a float, you're going to lose data. Yeah? So if it doesn't quite make sense, let me just make it concrete with an example. So the user wants to divide the number 25 by 2. All right, so in this case, the result's going to be 12.5. If you define the result variable as an integer rather than a double or a float, well, in Kotlin, it's going to round it to 12. So in this case, we could use some type conversion. So how do we do that? Okay, you got me convinced. Let's do it. Well, but first, before we jump in, there's a number of different methods used in Kotlin for this. That's why we're taking so long to delve in. So I'll have a look at these methods now. To convert any data type to byte type, the toByte method is used. To convert any data type to short, the toShort method is used. To convert any data type to the integer type, the toInt method is used. You following? So to convert any data type to the long type, yes, the toLong method is used. And any data type to the float type, the toFloat method is used. And to convert any data type to double, the toDouble method is used. Now, of course, there is another thing that you got to pay attention to. So you remember I shared the sizes of data types in the previous lesson? So let me just remind you once again here, the largest of the data types is double, then float, then long, then integer, then short, then byte. So if you convert a small value to a large value, there's not going to be a problem. In other words, if you convert a byte type to a double type, well, you will not experience any data loss. However, if you convert a large value to a small value, you may indeed incur data loss. For example, if you convert a variable of the type double to type integer, you will most definitely lose data. All right, my friends, so that's a little bit of inside info about this type conversion, but why don't we put it to good use and let's open up Android Studio and do some practice. So first I want to create a new Kotlin file. Now you could continue on the previous Kotlin file, but since I'm going to share these examples with you at the end of the section, I just want each topic to be a separate file. So you can follow the code according to the subject order. And, some people just like it that way. So I will set the file's name as type conversion. So now let's create the main method. So first of all, for your convenience, I will write out the type conversion methods in the comment line. toByte, toShort, toInt, toLong, toFloat, and finally, toDouble. All right, so now I can create a variable of the byte type here. So I'm typing var x:bytes equals 128. As you can see, Android Studio gives a warning. So why? Anyone? Anyone? All right, let me just tell you real quickly. A variable of the type byte could have a maximum value of 127. Therefore, we wouldn't be able to give this variable a value of 128 or more. So I'll just fix this and type in 127 here. Okay, so now let's create a variable of the type integer and pass the value of the variable x. All right, I'm typing var y colon integer equal, here, all right, x dot to int. See how that converts the x value of the type byte to type integer, all thanks to the toInt method, and it transfers it to the variable y. Now let's create a variable of the type double and pass the value of the variable y. So I'm typing var z colon double. I'm typing equals y dot to double. And that way we convert the y value of the type integer into double thanks to the method of type to double and transferred it to the variable z. So now we can print the x, y, and z variables to the console. So we will print the x value first. So just type in print in x. Now I can copy and paste this line twice. And I'll write y here and z here. Now let's run our code. And as you can see on the console screen, the value of the x and y variables is printed as 127. The value of the z variable is 127.0. So actually what we did here was type conversion from small to large. So we didn't lose any data. But I do want to show you type conversion from largest to smallest. Let's see what happens. First, I'll just convert these lines of code into the command line. Now I'll create a variable of type double, typing var a colon double equals 132.32. Just below the line, I'm typing var b colon integer equals a dot to int. Last but not least, I'm typing var c colon byte equals b dot to byte. And now let's print these values to the console. So I'm copying and pasting the above print in methods here. But instead of x, y, and z, I'll write a, b, and c. All right, so now let's run our code. So what you see here is the value of A is 132.32, while the value of B is only 132. So the value of C is a very different result, friends. That's because we try to convert a large number into a small number, and what did I tell you? We've got some data loss. So yeah, you've got to be forward thinking here and take it into consideration in future applications, because it could turn around and bite you where you don't want it to bite you. All right, my friends? So that is type conversion in Kotlin. We'll take a short break here, and then in the next lesson, we're going to learn about that string data type that I promised you about. All right? So I want to see you in the next one. Well, hello there, my friends. So in this lesson, we will learn string data types. Now, by string in Kotlin, we mean a set of characters, such as the word hello or the phrase, Kotlin is funny. When passing a value to a variable of string data type, we write the value to be passed between double quotation marks. So if you remember from before, we had a data type called char in our data types lesson. This char data type could only store one character, okay? But what if we want to pass an expression with more than one character to a variable? That's why we need to use the variable type called string. Now, in our example, it represents a string object in memory consisting of hello characters, right? So characters in a string are identified by their index number. In hello, in fact, the leftmost character H is at index 0. Next character E is at index 1, and then it continues numerically up from there. So the string class provides many useful methods to perform string operations. So have a look at the table. The length method returns the length of a string. It has no parameters. The equals method compares the string with a specified string and returns true if two string objects contain the same contents, else false. Follow? The isEmpty method returns true if the given string has 0 as its length. If the length of the string is non-zero, then it returns false. The plus method adds a string expression enclosed in parentheses to the end of another desired string expression. Lowercase method returns a string in lowercase. Uppercase method returns a string in uppercase. Now the trim method removes spaces at the beginning and end of the word. Cool. All right, so we'll move over to Android Studio and warm up with some practice. So before creating a new Kotlin file, let's just close these files that we created in the previous lessons, because now I want to create a new Kotlin file. I'll specify the name of this file to be string data type. All right, so we'll create a main method, and then I'll create a variable of type string. So I'm writing var a:\string here. After typing equals, you can type in any expression that you want to between double quotation marks. So I'm just typing in hello Kotlin. And now let's print the variable a to the console. So I'm writing print in a, and now let's run the code. Okay, so as you see, the console says hello Kotlin. And now I want to show you how we can concatenate two string variables. So for this, I will create a new variable of the type string. And here I write var b:\string. I write language between double quotes. Now let's print the variables a and b to the screen together. So I'm typing print in here. And write a plus b in parentheses. So the plus sign that we use here will concatenate two strings. So now we can run the application and let's have a look. And yeah, sure enough, it says hello Kotlin language on the console. But notice here that there's no space between the two words, right? Because this concatenation method adds the second word directly to the end of the first word. So how do you put a space between the two words? I'm glad you asked. I will show you. Since space will actually be of a type string, we can use double quotes and leave one space. So in parentheses, a plus double quotes, I leave a space, plus b. Let's run our code one more time. And there you have it. There is now a space between the words hello Kotlin and language. So what we did here was concatenated two different string expressions. So now let's print two variables of type string and integer to the console. Yeah, so for this, I will create a new variable of the type integer. I write var age:\int and pass the value 25. Now let's print your age is 25 on the console. So after typing print in, I write your age is in parentheses between the double quotation marks. And after leaving one space, I write plus age. Ah, see. Now let's run our code. So as you can see, it says your age is 25 on the console. Cool. I could see that you were getting it right as we were going along. So we're going to be using this a lot, okay? Very, very, very often. So we can learn some of the methods that are used in the string class. All right, so first of all, I'll just convert the codes that I wrote here into a comment line. Now we'll create a new string variable, var x :string equals, and I'm writing Kotlin. So now let's use the length method first. Now, if you remember, the length method gives us the size of a string variable. So now I want x.length on a bottom line. Of course, this method will give us the length of the Kotlin word in the integer type. So if you press the Control and Space keys on the keyboard after you move the cursor to the right of the length method, well, you can open a suggestion window here. What do you know? So you see, therefore, it would be more logical to pass this value to a variable of type integer. That's why I'm typing var I: int equals here. Thus, the length of the Kotlin word will be calculated with the length method and then passed to the variable I of the type integer. Then finally, we can print this I variable to the console. So I'm writing print in parenthesis, and between double quotation marks, I write length of Kotlin equals, and I write plus I. Cool, so now let's run the code. And as you can see, the length of the Kotlin word on the console screen is right here. That is, how many characters it consists of. So that's how you use the length method. Now let's have a look at how you use the equals method. So what I'll do is convert the codes here to the comment line, but I will not delete the x variable. We can use that. So I'm typing x.equals here. I'm typing in parenthesis between double quotes in Java. So if the value of the variable x is equal to the Java word, it'll give us the value true. If not, it will give us the value false. So as a result, it's going to return a Boolean value, right? Therefore, I will pass this result to a variable of type Boolean. So here I write var b: Boolean. Now let's print variable b to the console. So I write b in parentheses. Okay, so now let's run and test it out. So as you can see, it prints the false statement in the console. So now we can compare two different string expressions using the equals method. All right, so yes, there's more. Let's have a look at the isEmpty method. So this method also checks whether a value is passed to a string variable, and if not, it returns false. I'm also converting the codes here into comments. And now I'm typing print in here, and I'll write x.isEmpty in parentheses. This way we can print the true or false value directly to the console. And as you can see, we saw the false value in the console because the variable x is not empty and the value Kotlin is passed into it. So now let's have a look at the plus method. You can concatenate two string type variables using the plus method, right? So I'm typing print in right here, writing x.plus in parentheses, and we should write an expression of type string inside these parentheses. So I'm typing language here. Cool, so now let's run our code. And as you can see, the Kotlin language is written to the console. So now let's have a look at the lowercase and uppercase methods. These methods also convert all letters in a string type expression to lowercase or uppercase. So why don't we test it out? So here I'm typing print in. I write x.lowercase inside the parentheses. Now I'm going to the bottom line. After typing print in, I write x.uppercase. And also, to separate these two lines of code, we can apply a method like this. So I'm typing print in right here, and I'm doing a partition by pressing the asterisk key right on the keyboard between the double quotes and parentheses. So you can use this method when you're not going to print multiple data to the console. So now let's run our code, and you can see, first, all letters of the word Kotlin are printed in lowercase, and then all letters are capitalized. And see, both expressions are separated by asterisks. Okay, so finally we'll learn the trim method, and we can wrap this lesson up. Of course, you remember, trim method was also for removing spaces at the beginning and at the end of string expressions. For example, let's say you made an application that asks the user for a username and password. Well, the user may have accidentally put a space at the beginning or the end of the username. People do that. Yeah, right. So in this case, if you do not delete this space while storing the username, the user may encounter an error the next time that they log into the application, won't be able to log in, and then they'll go crazy. Okay, so in these cases, the trim method is used. So let's now reinforce this issue with an example. So here I'll just create a new variable of the type string, and I'm writing var t:\string. After double quotes, I put 3 spaces and type Android. So after typing Android, I'll leave 3 spaces again. Now let's print the variables x and t together to the console. First, I will print without using the trim method. So I'll write x plus t in parentheses. Just the bottom line this time, I will use a trim method. So here I'm typing x plus t dot trim. All right, so now let's run our code. And look at that. As you can see, it was first printed with spaces, and then it was printed after it removed the spaces in between. What do you think of that? Some kind of magic? I don't think so. That's Kotlin. All right, so my friends, that is how you deal with string variable types. So we'll take a short break here, and in our next lesson, we're going to learn about the array variable type. All right, there's a lot packed into arrays. So I'll see you next time. Well, hello, my friends. So in our previous lesson, we introduced the concept of arrays, right? So in this lesson, we're going to talk about array lists. So I'm sure you remember after we created the array, we couldn't add a new element to the array that we created. But there is a method for this. We need array lists. So why don't we just go ahead and have a look at how to create these array lists? So we can create the array list in 2 different ways, it turns out. Well, the first is very similar to the method that we created in the first or previous lesson here. All right, so after specifying the array name, we could write array list of on the right side of the equals. So we also need to specify the type of array here. We also need to write the array type between the chevrons. All right, so that's the first method. But in the second method, after defining the name of the array, we write array list to the right of the equals. And again, we write the type of the array between the chevron sign. So the difference between these 2 methods is that in the first method, you can specify the elements of the array while you're defining the array, or you can add them later. But in the second method, you can add elements to the array only after having created the array. Okay? So in other words, here, the choice is up to you. You can choose any of these 2 methods depending on the application that you're going to make. So now let's see how we can add elements to array lists, since we're doing it right here. We can now use the add method for this. Of course, we could use the add method in 2 different ways. Full of options we have here. So in the first method, we can just write the element that we want to add. In this case, it always adds the element that we want to add at the end of the array. In our example here, the last element of the index, that is the 3rd index numbered element, would be 20. Or we could specify the index number of the element that we will add, right? So in this case, we would need to write two parameters in parentheses. The first would be the index number, and the second is the element that we will add. Now we can also delete any element from array lists, and for this we could use a remove method. Again, it's possible to use the remove method in two different ways. So in the first method, we can write the element itself. In the second method, we can remove the element from the array by specifying its index number. All right, so that's all you need to know about array lists. Why don't we go ahead and move on over to Android Studio and put it into practice. So I just want to create a new Kotlin file. And here I'll specify the name of this file to be array list. Now let's create our main method. So first I will create an array list of type integer. And I'm writing var age equals array list. We'll also specify the type of array between the chevron marks here. So here I'll write int, and finally I'll put in parentheses. So we've defined an array list named age and type integer. Now let's create the elements of this array. So on the next line, I will write age.add. I write 10 in parentheses. And just by doing that, we added an element to the array list named age. Now let's add the second element. So this time I'm going to add the index number by specifying it. So I'm writing age.add, and I'll write 1 in parentheses. So this represents the index number, yeah? Since, of course, the number 10 we just added is the first element, the index number was 0. This will be the second element, so the index number must be 1. Now, let's write the value of the second element. So I'm typing 15 in here, and thus we have determined the first two elements of the array list named age. So why don't we go ahead and add one more element and print these elements to the console. So I'm writing in age.add. I'll write 20 in parentheses. Now let's print these elements to the console. So I'll type s out and press enter. And if you remember, this method was creating the print in method quite quickly. So I'm writing the first element of age array list in double quotation marks inside the parentheses. And after typing the plus sign, I'll write age and open square brackets. I'll write 0 here. So in other words, we print the element of the age array with the 0 index number to the console. Now I can copy and paste this line twice. So I'll type second here. I'll write third here. Cool. So now let's print the second and third elements. Now, here I want to show you something a little different writing styles, okay? So to print the second element to the console, I'll write age.get, and I write 1 in parentheses. And there's really no difference between this type of writing and the way that we're going to write it in the next line. You can use both. So now let's print the third element to the console. But here I want to talk about a writing style that I haven't yet mentioned. So I'm going to show you how to write any line of code in a string expression. Now, if you've noticed, whatever we write inside the double quotation marks here looks exactly the same in the console. So you could say that it's not detected to be code. So if I cut the age2 expression here and write it in double quotes here, it will appear exactly like this on the console screen. So we wouldn't be able to learn the third element of the array. So what could we do for this expression so that it would be perceived as code? Do you know? Take a guess. Or no, that's why you're taking this course. Okay, well, I'll continue. But what would happen if you put a $sign at the beginning of an expression that you want to be treated as a code in double quotation marks? And then enclose that expression in curly brackets. The expression after the $sign will be treated as code. Now, we don't use this spelling very often. It is useful to know. So now let's run and test our code. So as you can see, we've printed 3 elements of the age array list to the console. Now, if you want to use the remove method, I wonder if you remember, we could remove any element of the array from the array list with a remove method. Yeah. For example, let's just remove the second element of the array, 15, from the array. So for this, I'll write age.remove. And if you use the remove method, you must directly write the element itself in parentheses. So if you use the remove at method, then you must write the index number of the array you want to remove in parentheses. So I'm using the remove method right now. You can go and test the other method yourself, but I want to show you this. So write 15 in parentheses. Of course, when we delete the second element of the array from the array, the third element of the array, 20, will now become the second element of the array. So now, let's first print the size of the array to the console. So for this, I can write age.size in parentheses. Now let's print the first and second elements of the array. For this, I can copy and paste the above lines of code here. Now also, before running the code, let's convert these lines of code to the comment line. All right, so now we can run the code, and we should be able to see the numbers 2, 10, and 20 on the console. And as you can see, we have printed the size of the array, its first and second elements, right here to the console. So now, let's try this. We'll create an array using the ArrayListOf statement. And this time, we're going to create an array of type string. So I'm writing var cars equals array list of. The type of array will be string. And now we can specify the first 2 elements of the array here. So I'll write opal in parentheses as the first element. Second element, I'm going to write BMW. Now we can add the third element of the array using the add method. So here I'll write cars.add. I'll write Ford in parentheses. And now let's print the elements of the array to the console. So for this, I'll copy and paste the lines of code that I wrote above. And I should write cars instead of age here, because the name of our array is cars. Yeah? Good catch. Finally, let's run and test our code. So as you can see, we printed Opel, BMW, and Ford on the console. And as you can see, guys, we can create array list using both methods, right? That's cool. Now, I do want to show you one more thing, and then we'll wrap this lesson out, okay? So if you remember, in our array lesson, we created an array containing both string and integer expressions. And yes, this is also possible with array lists, my friends. So in other words, there may be different data types in the array that you want to create. Totally doable. But for this, my friends, you will need to define the type of the array as any. All right, so let me just show you a quick example. So here I'm writing var mymix array list equals. So after writing an array list, I set the type of the array to any. Now let's add an element to the array. Let the first element be of type string. So here I write my mix array list.add. I write Ford in parentheses. Let the second element be of the type integer. So I write my mix array list.add. I'll write 5 in parentheses. And we'll make the third element be of the type double. I'll write myMixArrayList.add. I'm writing 2.5 in parentheses. And let's make the fourth element be of the type Boolean. So I'll write myMixArrayList.add. I write false in parentheses. Now the fifth and final element will be of the type char. So I'll write myMixArrayList.add. I write K in single quotes in parentheses. So now let's quickly print these statements to the console and see what we get. So I'm writing myMixArrayList square bracket 0 inside the bracket. Now let's copy this line and paste it 4 times. Now let's edit inside the square bracket. Finally, all right, 4. All right, so now let's run and test our code. And as you can see, we have printed the elements of the array list, which consists of different data types, right here to the console. All right, my friends, so that's how you use array lists. I'll tell you, we're going to be using array lists a lot, just a heads up, when we're doing our Android applications. So get used to it, and hopefully you get the logic. Of course, we're only showing you just the bare bones of it. So yeah, I might have heard a couple of snores out there, not sure. But when you start developing your Android apps using this information you've learned, oh boy, you're going to see how it makes it such a joy. Truly. All right, so just be a little patient in the beginning and learn it all, and we'll just have a short break here. Want to see you in the next lesson, which starts in the next video. See you then. Well, hello, my friends. So right now we're going to take a closer look at this if-else-if. We call it a ladder statement and a nested if statement. We're going to take a look at the syntax. So first, the Kotlin if-else-if ladder statement executes one condition from multiple statements. And secondly, the nested if statement represents the if block within another if block. So here, the inner if block condition executes only when the outer if block condition is true. All right, so let's do some examples with an if ladder and nested if statements. First up, what do? Create a new Kotlin file. Right-click on the package name, select the new Kotlin file option. So I'll determine the file name, and here I'll just call it if ladder nested if. Enter, and create a main method. Write main, select main A option, hit enter, and there is the creation of the main method. All right, so we're going to show a message to enter age by using the print method. And we will declare a variable, your age, with int type, and assign the readLine method to this variable. Also, I'm going to convert to the integer using the toInt method. Okay, so let's start to write the if statement. If your age is less than 13, then we will print you are a child to the output. Else, if your age is less than 19, we will print you are a teenager to output. If your age is greater than 19, else statement is executed, and we will print you are an adult to output. If all test conditions are false, codes inside the body of else is executed. Okay, so let's run the code. So back over on the console screen, let's enter 8. 8 is less than 13. So first if statement is executed. Output is you were a child. Cool, so let's run the code again. And let's enter 15. The program checks the first if statement. 15 is greater than 13, so the first if statement is not executed. So the second if statement is checked. 15 is less than 19, and yes, this condition is true, so this statement is executed. So then the output is you are a teenager. All right, so let's run the code again. Let's enter 45. And the program checks the first if statement. 45 is greater than 13, so the condition is false. The program then checks the second if statement. 45 is greater than 19, so the condition is false. The else statement gets executed, so the output is you are an adult. Now, I want to add a nested if statement in the else statement. You'll see. So, if your age is less than 65, then we will print you're an adult to output. We add the else statement means that if your age is greater than 65, we will print you are a senior to output. Okay, so let's run the code. And in the console screen, let's write 56. Else statement gets executed because 56 is greater than 13 and 19. In the else statement, 56 is less than 65, so the if statement is executed, and the output is you are an adult. But now let's run the code again, and we'll enter 68. In the else statement, 68 is greater than 65, so the else statement gets executed, and the output is you are a senior. Yeah, you see how that works. So let's write a Kotlin program to find the largest of three numbers and implement a nested if statement. You with me? So first of all, let's convert the lines of code that we wrote here to the comment lines. And we'll show a message to enter three numbers by using the print method. So let's declare four variables whose names are number 1, number 2, number 3, and largest number with the integer type. And assign readline.toInt methods to these variables. Now look, I'm not going to set the initial value of the largest number variable. Instead, I will pass the largest of the three numbers entered by the user into this largest number variable. So if you're within the bounds of a function, you may not be able to initialize variables. Yeah, we're going to cover that topic a little later in the next lessons, but let's start to write the if statement. So if number 1 is greater than or equal to number 2, this is outer if, yeah? So we add a nested if statement. If number 1 is greater than or equal to number 3, then assign number 1 to largest number. Now you're getting it. Else assign number 3 to largest number. All right? So why don't we continue with the outer else statement? We'll add a nested if statement again. If number 2 is greater than or equal to number 3, then assign number 2 to largest number. Else assign number 3 to largest number. Yeah, you're cooking with gas now. So let's print the largest number to the output by using the print method. Okay, you ready to run the code? So in the console screen, we'll enter 6, 5, and 12. So the program will check the outer if first. 6 is greater than 5. The condition is true, so outer if gets executed. In the outer if, the program checks the inner if. 6 is less than 12. The condition is false, so inner if is not executed, and the else statement gets executed. And 12 is printed as the largest number. Very cool. So let's run the code again. But this time we're going to enter different numbers. How about -2, 1, and 0? And as you can see, the largest number is 1. Ha! So what do you think of that? I think it's pretty cool. So thanks for sticking with it. And that's enough of the example stuff, right? At least to understand the if statements. To make it clear, though, you got to do some more exercises. So stay tuned for the next video. See you then. Well, hello, everyone. So in this video, we're going to learn how to use the when statement and understand how to control the flow of our program's execution. So the when statement executes one statement from multiple conditions. So you might think it's like the if-else-if ladder statement that you learned in the previous video. The when statement works with data types such as byte, short, int, long, and string. As you can see in the diagram, when the statement starts with when, which is a keyword, and a conditional expression between brackets. If condition 1 is true, code block 1 gets executed. If condition 1 is false and case condition 2 is true, code block 2 is executed. If condition 1 is false and condition 2 is false, if condition n is true, code block n is executed. Now, if all case conditions are false, the codes in the else block are executed. Now, there are some important points when you're using this when statement. So let's consider them. There can be one or n number of case values for a when expression. The case value must be of when expression type only, and the case value must be literal or constant. We cannot use variables here. So let's make some examples, and we'll use some when statements. So first, I'm just going to create a new Kotlin file, so I'll right-click on the package name, select the new Kotlin file option. After selecting the file option here, I'll determine the file name, and I'll just call it when statement. Hit enter. So now I've got to create the main method. I'll write main and select the main A option here and enter. Okay, so now we've got the main method created. So let's do up our example like this. We'll ask the user to enter a number between 1 and 7 into the console, right? So we'll print the day of the week to the console according to the number entered by the user. So, for example, if the user enters the number 1, we'll print Monday to the console. If they enter the number 7, we'll print Sunday on the console and everything in between. All right? So let's get right into it. First up, we'll prepare a message that informs the user. So let's write, please enter a day number of the week here. Now I'll create a variable of the type integer called day number. Then I'll pass the value entered in the console to this variable. Now let's create a variable of the type string. but we cannot initialize this variable, right? So we're going to pass the days of the week to this variable. Now, let's create the when statement. So I type when, and then select the when option suggested by the editor. So I'll write the day number variable inside parentheses because we have to pass a value entered in the console to this variable. Okay, so now let's create the conditions. So I'm writing 1. Then I'll add a dash and a greater than sign. This expression is called the lambda. All right. So after the lambda, we must define the operation that needs to be done. So if the user enters a number 1 in the console, we should print Monday to the console, right? So for this, I'll pass the value Monday to the day variable. And that's how we've created our first condition. Yeah, so now we have to create the other 7 conditions. So for this, I just need to copy and paste this condition 7 times. Then if the user enters the number 2, let's make it Tuesday. If the user enters number 3, it'll be Wednesday. Enters 4, it'll be Thursday. 5, it'll be Friday. 6, Saturday. And finally, if they enter the number 7, it will be Sunday, Sunday, Sunday. All right, so now if the user enters a different number, we've got to create that else condition for that scenario. So in this case, we can pass the following expression to the day variable, invalid day choice. So now why don't we go ahead and print the day variable to the console outside of the when statement. So after typing S out, I'll press enter and I'll write day is $day in parentheses. Okay, so now let's run the code. Enter 3 for the day number of the week. Case condition 3 is executed and day is Wednesday is the message that gets displayed. Cool. So let's run the code again. Enter 5. Case condition 5 is executed and day is Friday is the message that gets displayed. All right, so let's see what happens when we run the code and enter 8. See, so the default part of the when statement gets executed and the invalid day choice message gets displayed. Perfect. So yeah, my friends, now you get a pretty good understanding of how that when statement gets used. So why don't we just take a short break here, and then in the next lesson, we're going to learn some loops, all right? So I'll see you on the other side. Hello, everyone. All right, so in this video, we're going to learn about the do-while loop. Now, the do-while loop could be considered similar to the while loop, with the only difference is that it checks for the condition after executing the statements in the loop body. So in other words, there's no checking of any condition at the outset, okay? So after the execution of the statements in the loop body and the update of the variable value, the condition is then checked to be true or false. So then if it's evaluated to be true, well, the next iteration of the loop starts. If the condition returns false, the loop terminates and jumps to the next statement after the do-while loop. So the statements in the loop body are executed at least once before condition controlling. That is the most important point. So, why don't I show you a few examples with this do-while loop. First up, I'll create a new Kotlin file. I'll name this file as do-while loop. And now let's create the main method. All right, so we'll write a program that prints int numbers from 1 to 15. Let's declare a variable number with initial value to be 1. Now let's start the do while loop with the do keyword. Now in loop, we'll use the print method to display numbers. So I'll put a $sign before the number. We need to update the variable number. So we increase the value of number by 1. And now we add a loop condition with the while keyword. Our condition is number is less than or equals 15. All right, so let's run the code, see what we get. And look, what about that? Here are the numbers from 1 to 15 right there on the screen. So in the do while loop, the print process and increment part of the body is executed at least once before the condition. All right, my friends, that's how the do while loop works. So yeah, we've learned about the loops that we use in Kotlin. So just want to take a quick break here and we'll talk about methods in the next video. All right, so see you in the next one. Well, hello everyone. So in this section, we're going to introduce functions in Kotlin. Yeah, so first we'll learn what is a function and how do you create a function in Kotlin. We will then learn declaration and calling of functions. Then we will learn function types. And then we will learn function return types. All right, so a function is a set of statements to perform an operation. Functions are also known as procedures, as well as functions. The main advantage of function is code reusability. So you can write a function once and then use it multiple times. You do not have to rewrite the entire code each time. So you can think of it like write once, reuse many. I don't know. I thought it was going to be cool, but, you know, one to many, once many. Once you write it, you can use it a lot. All right, so you see the general form of a function declaration right here. A return type is a data type of the value that is returned by the function. It can be a primitive type, such as int, a class type, such as string or unit. Each function has its own name. So a function name begins with a lowercase letter and compound words. So in multi-word names, the first letter of each of the second and following words need to be capitalized. Now, we're going to discuss our naming rules for functions in the coming lectures, but for now, just park that in the back of your head. A parameter is a value passed to the function. Functions can take one or more parameters. So if the function has more than one parameter, then these parameters are separated by commas. If functions work with data, we must pass the data to the functions. And this is done by specifying them inside of parentheses. If the function does not take any argument, simply leave the parentheses empty. If any function is not declared unit, then it must contain a return statement with a corresponding return value. The data type of the return value must match the function's declared return type. So you can't return an integer value from a function declared to return a Boolean, right? That makes sense. But don't worry, we'll cover function return types in much detail coming up. So the function body, which is enclosed between braces. The function body includes the declaration of variables and some other codes of functions. Now, finally, in our example, we define the function that its name is addNumber with the integer data type, and we have x and y parameters. Our function finds the sum of x and y and saves the result in a new variable sum, and then returns the value of that variable sum. Also, we can directly return the x plus y statement instead of assigning a new variable. So my friends, this is the general structure of functions in Kotlin programming language. Now, of course, we can use this function that we created wherever we want. If we do not use it, the operations that we define inside the function will not occur. So in other words, we have a function, but the function cannot perform its function. So how can we call a function that we created? Well, that's what we're going to find out right now. So a Kotlin function is called according to its functionality. It is called in any of these two situations. The first one, when it completes all the statements, and then the second one, when it reaches a return statement. So in this example, we'll define a variable result with the int data type. Its initial value is 0. We call the add number function with arguments 10 and 20. Argument values are passed to the parameter. Arithmetic sum is the operation that gets performed in the add number function, and the return value of add number function is assigned to variable result. And now we show the result value 30 on the screen. Also, we can directly use the add number function with the print-in function instead of assigning a new variable. But as you see, the result is the same. All right, my friends, that's in general how you use functions in Kotlin. Now, don't worry, though. We're going to go over it a lot because we're going to reinforce this subject by doing many, many examples in a little bit. But first, I bet you want to learn the types of functions, right? So we're going to take a short break here, and I will see you in the next video. All right, hello, friends. So in our previous lesson, we talked about constructor theoretically, but we also learned how to create classes and objects in Kotlin practically, right? So that means in this lesson, we're going to do a little practice with constructor. All right, so let's get to it. Now, hopefully you remember we created a Kotlin class called cars in our previous lesson. Now, this Kotlin class also had two properties, name and model. We also created two objects of the cars class in the main method. Great, and then using these objects, we passed some values to the name and the model variables. Now, did you notice we first created an object and then passed a value using the object? So what do you think we ought to do if we wanted the user to transfer these values while creating an object from any class? So this, you understand what I'm saying, right? Well, I'll tell you, because we're going to make a constructor. The constructor was the first method called when creating an object from a class. So why don't we do this? Let's create a new class right now, and we'll try to understand the constructor just a little bit better using this class, all right? So first, just right-click on the project package folder, choose New Kotlin Class File option. Now here, the class is going to be selected, so why don't we call this class My Cars? I'll create the Kotlin class just by pressing Enter. Now, do you remember when we talked about the constructor in the previous lesson, we talked about two different constructor structures in Kotlin, and these were primary and secondary, right? So we'll have a look at the primary constructor first. To create a primary constructor, we'll write the constructor expression after the class name. When we start to write the constructor, the code editor proposes that constructor to us. Select it, press Enter. Now, write the name and the model variables in parentheses. Cool. So here I'm writing var name : string. And after putting in a comma, we can define the model variable. So I'll type var model : int. All right, so here we've created the primary constructor. So now let's create an object of this class in the main method. We'll turn the codes that we wrote in the previous lesson into a comment line. Let's write creating an object from class here. That way you'll be able to understand these codes a little bit more easily when you go back and review them. All right, so let's create an object from the myCars class. And here I'm typing var myNewCar equals myCars. And see how Android Studio gives a warning? Because we need to enter a name and model parameters in parentheses, because we wanted the name and model parameters to be entered in the constructor, right? Now at this point, hopefully you understand the purpose of the constructor. You see, if we did not use the constructor, we could create objects without entering these parameters. However, sometimes we may want to enter some parameters while creating objects with the projects that we develop. You follow? So in this case, it is best to use a constructor. All right, so without any further ado, let's enter some parameters. I'll write Ferrari as the first parameter. Right, 2021 is the second parameter. Now let's print these values to the console. I'll type S out and press enter. I write my car's name is myNewCar.name. And its model is myNewCar.model in parentheses. Now let's run our code. All right, so as you can see, we've printed the name and the model of the car on the console, okay? So that's how you use the primary constructor. Now I want to show you something, how to use the init keyword. So in Kotlin, you wouldn't be able to directly write a block of code inside the primary constructor. If you want to write some code, you should be doing so using the init keyword. So I'll give you an example. Let's try to print the name and the model of the car to the console, not in the main method, but in the constructor of the myCars class. All right, so I'll first convert this line of code into a comment line. All right, so now let's go back to the myCars class. I'll write S out here, but as you can see, we cannot write S out. More precisely, we encounter this error when trying to write it. Okay, so this is because no code can be written directly into the primary constructor. So for this, we need to use the keyword init. So after typing init here, I'll select the init expression suggested by the code editor and press enter. What happens next? A block is formed for us. So now let's try to write S out inside this init block. And as you can see, we don't encounter any more errors. So I create the print in method by pressing enter. In parentheses, I'll write my car's name is $name and its model is $model. Let's run our code again. And here you can see we were able to see the name and the model of the car on the console screen. So my friends, that is using the primary constructor in Kotlin. Now, let's have a look at the secondary constructor, all right, because we've built it up pretty big here, huh? I already told you that the secondary constructor is similar to the constructor in Java. So that means you can create multiple constructors using the secondary constructor. Of course, if there are any friends out there who know Java programming, we could create empty and full constructors in Java, right? You can create empty and full constructors just by using the secondary constructor in Kotlin as well. So let's do that right now. First off, we'll create a new class. So in fact, we can explain all of these concepts through the same class, but since I do want to share these codes with you, I just want to examine them a little more easily. So for that reason, I'm just going to explain it in separate classes as much as is possible, all right? So here we can just put the name of this class to be my second cars. All right, so now let's create two variables for this class. So here I can type var name column string question mark equal null. Just below the line, I'm typing var model column int question mark equals null. Now, let's create the secondary constructor. There are actually two different ways to create it. The first is manually. The second one is using a shortcut in the code editor. So I want to show you how you do it manually first, because then you'll understand what the shortcut does. So when I write the constructor here, I'll select the constructor suggested by the code editor and press enter. Now, if you leave it that way, it is expressed as an empty constructor. But we will create a full constructor. That is a constructor that includes both variables. So for this, I'll write the name column string in parentheses, and I'll write the model column int after the comma. Now, I'll open curly braces and specify the scope of this constructor. Here, using the this keyword, we will pass the name and model information that will come from the main method with the help of the constructor to the name and model variables that we have created here. All right, so let's do this right now. So I'm just typing this dot name equals name here. And this is the first time that you see this type of writing, you know? So let's try to explain a little bit. This keyword represents a class to which the method is bound. So here it represents the mySecondCars class. So the name that comes after this statement represents a variable named name that we created in the class, right? The name that we write to the right of the equal sign represents a value that we will specify in the main method with the help of the constructor and will be transferred to the variable named name. You can also write a different expression instead of name here. For example, you can write n instead of name. It's not going to cause any errors, but the secondary constructor is generally adaptable in this way. So, similarly, now I can write this dot model equals model. So we created the secondary constructor like that. So why don't we do this? Let's create the secondary constructor using the shortcut in the code editor. So let me just delete the constructor here. I'll right-click on the empty space. Choose the Generate and Secondary Constructor options from the pop-up menu. So if you notice, we can see the variables named name and model in this window. And if you press the Select None button without selecting these variables, you will get an empty constructor. But right now, I want to right-click and select the Generate and Secondary Constructor options. That would be an interesting new word, huh? Anyway, this time I want to choose both variants. So you can select both variables just by pressing the Control key on the keyboard. So I'll create the secondary constructor by clicking the OK button. And as you can see, the secondary constructor is created automatically, just like that. Now, of course, you could use either one of these two methods, however and whenever you want. But now I want to create an object of this class in the main method. So here I will write var mySecondCar equals mySecondCar. Now notice that although we create the constructor, we do not get an error, even if we don't write any parameters in the parentheses. Can you tell me why? Well, I'll tell you. It's because we are creating an empty constructor, right? So why don't we do this? Let's turn the empty constructor in the class mySecondCar into a comment line. Now, if we look at the main method, as you can see, we are now getting an error, right? Because there's only a full constructor and we need to enter parameters here. So what do? I'll write Mercedes as the first parameter. I'll type in 2000 as the second parameter. Now, let's print this to the console. So I'm copying the line of code here and pasting it here. I'll type in second here and also arrange these objects as my second car. Now we can run our code.
As you can see, we have printed the name and model of the car on the console. Yes, friends. This is how to use the primary and secondary constructors in Kotlin. I hope it has been a useful lesson for you. Before I end the lesson, I want to show you one more thing. Notice that we have set the value of the variables named name and model during object creation. This was because we created the constructor. Well, can we change the values we assign to the objects named name and model? In other words, is it possible to change the values we assign while creating an object later? Let's explain this situation with a simple example. Currently, the value of the variable name is Mercedes and the value of the model variable is 2000. Now let's change these values. Here I write my second car, .name equals. This time let's name the car Opel. Similarly, let's pass a value to the model variable. I'm writing my second car, .model equals. Let's transfer the value of 2010 to the model variable. So, when we run the code, do you think we will see the new values or the old values on the console screen? Any ideas? Let's run the code and see together. And as you can see, we saw the new values, namely Opel and 2010 values, on the console screen. This is because the set method is automatically created in the Kotlin programming language. If you want, let's end this lesson here, and in the next lesson let's focus on set and get methods and encapsulation. See you in the next lesson.
All right, so hello. And what do you think we're going to talk about in this video? I think it's got to be layouts. Yeah, because that way we'll be able to do the design level in Android Studio. But before we get to the design level, we got to learn about layouts in order to design the Android applications, right? So what is this layout thing all about? So layout. It's an interface that we use to place Android components on the Android application, right? So we use layouts to establish components in a particular order. And these components are comprised of buttons, text views, radio buttons, all kinds of different things. There's varieties of layouts. So these are linear layout and relative layout. You got your table layout and constraint layout, right? You might have heard me talk about that before. So these are the main layouts, and we're going to talk about now the first three of these. So in particular, this constraint layout, we're going to leave that to another video. Now, for most of the projects that you're going to do and that you'll surely do with us here, we'll be using the linear layout and the constraint layout. But if you have a table design in your project, you got to use the table layout, right? Now, I want to tell you about all of this through Android Studio, if you will. So why don't we just go to Android Studio right now? So you know that we've got a project. We've done that before. This name is My Android Project, unless you changed it. So let's just close this project right now, and we'll create a new project. So click on the File tab in the upper left-hand corner. Actually, you can create a new project by selecting the New Project option, but I'm going to close this project and create a new project. So that's why I'm going to choose Close Project as my option. All right, so as you can see, we've encountered the Start screen of Android Studio. And from here, I'll select the New Project option. Then from this window, I select the Phone and Tablets tab, and then the Empty Activity option, and press the Next button. Now from this window, we're going to configure our project. So I'll set the name of the project as Layouts. Now I'm not going to change the project package name, and I won't even change the file path where the project will be saved. The programming language will be Kotlin. Minimum SDK level can be 23. All right, so I create my new project just by clicking on the Finish button. All right, now at this stage, we have to wait for the project to be fully created. All right, so here is our project created. Now, when we open a new project in Android Studio, it creates the activity main.xml file. So now I can click this tab and open the design area. Now we're going to do our application design on this page. So first of all, to make the design area look like a phone screen, see this little eye icon here? Click on it and select the Show System UI from here. And as you can see, the action bar, the navigation section, it's all right here. And this page's default layout, well, this happens to be the constraint layout, right? So for now, we will not use the constraint layout, though. We're going to start with the linear layout. So have a look at the components section. All right, you will see the different layout types under the layout section. So before we continue talking about layouts and doing what we're going to do, I'm just going to delete the text view component here. So I'll select the component, press the delete key on the keyboard, and there it goes. Now we're going to continue. So first, I'm going to change the constraint layout. And instead of constraint layout, I will write the linear layout. And I'm going to do this using XML code. So to do that, I'm going to open the XML side just by clicking the Code tab in the right corner up here. Yeah. So this whole thing is a design area, and you've got this Code tab up in the upper right-hand corner, right? Now you could also click the Split tab for XML and Design to appear side by side together. Also, if you want, well, we could just close the project directory just by pressing the minimize icon right here. All right, so there's a few options for you. Now we're going to move on and change this constraint layout. So for this, I'm going to delete the constraint layout. And after that, I'm just going to write in here, linear layout. Now, when you start writing linear, the code editor offers you linear layout. Pretty cool, huh? So from here, you can just create the linear layout by selecting the linear layout and pressing the Enter key. Very cool. So now our layout is linear. But also we've got to specify its orientation. Can't just leave it like that. So you got to see that there are two different types of linear layout. One is horizontal, the other is vertical. You can specify that by writing the orientation keyword here. Select the Android orientation option, press Enter. So now we've got to select the orientation type. So I'm going to choose vertical as my orientation. So now in this layout, components are placed from the top down. If you choose horizontal orientation, components are going to be placed from left to right. All right, so how does it look? Well, let's go back to the design area and we'll get a closer look at this linear layout. All right, for example, I'm going to put in a text view here. Of course, you may not know the components yet, such as text view and button, and don't worry about it. We're going to learn all these components as we go along in detail. But for now, we are focusing on layout, so just follow me. So if I find the component that we're going to add to the design area right here from the palette section and select it, I can then just drop it into the component tree here with the drag and drop method. And you see it started from the top. And after that, I will add a button, same way. And you see it's placed under that. So if I add another button, it's placed under the first button. So now I'm going to change the orientation of this linear layout. I'm going to change it to horizontal. Now let's have a look at the design page again. But now, what is that? So did you notice? Only the text view component appears on the screen. Why? I'll get to why in a moment, but now I just want to change the layout width property to wrap content from this attribute section. And now you can see buttons and text views are sorted from left to right. So if I add one more button, it's going to take its place after the second button. All right. So there's a visual understanding of the difference between vertical and horizontal, right? Totally changes what you can see. So before we continue, I'm going to make this orientation back to vertical, and it'll be the way that we work with our linear layout. All right. Now let's have a look into the attributes of the layout, and we'll be able to change them. Now, I ought to mention too the layout width and the layout height. These are two properties here. They are match parent and wrap content in here. So when you choose match parent, what's going to happen? The layout will cover the entire screen. But if you choose wrap content, the layout will be big enough to enclose the whole content. Also, you could get a numerical value for these properties. And what I mean by that is you don't have to choose just match parent and wrap content. For example, let me give a layout width 300 dp and layout height 400 dp. And you see what's happening. Now also you can add more than one layout. I'm going to choose layout width and height match parent. And I'm going to add another layout, but this time its orientation is going to be horizontal. So I added this under the vertical linear layout, see? I will add two text views under this horizontal layout. I will choose layout width wrap content for the horizontal layout. And now you can see these two text views side by side. So in the same way, I'm going to choose layout height wrap content for the horizontal layout. So now you can see the button too. So now these two text views depend on the horizontal layout. The button depends on the vertical layout. Actually, the button and horizontal layout are elements of the vertical layout. Also, the horizontal layout has two more elements that are text views. So now I'm going to add one more button here, and it will take place under the other button. See that? Now also, I could add one more layout. This layout is also a horizontal layout. This layout is the element of the vertical layout. And I will connect these two buttons to this new layout. And I'm going to do that on the XML code side. So I will cut these two buttons XML code and paste them inside the layout. See how that works? And also I'll choose layout with wrap content for this. And now we have one main layout and its orientation is vertical. We also now have two child layouts and their orientation is horizontal. And every horizontal layout has two childs as well. These are buttons and text views. Yeah. People typically say children, but I just wanted to give you that extra bit of clarity. All right, so moving on. So we got the linear layout. We can now continue with the relative layout. So I'm going to delete these components. So delete any component, by the way, just simply select the component you want to delete. And guess what? Press the delete key on the keyboard. And I'll change the linear layout to the relative layout. So for this, I'm going to open the XML site again. I write relative layout instead of linear layout. And thusly, our main layout in the design area becomes the relative layout. All right, so how does this relative layout work? So let me first of all point out the relative layout is a very old layout, and we're almost never going to use it in our project. But you got to notice that we cannot see the relative layout component in the layout section of the palette, because the relative layout is seriously not used much anymore. It's been moved to the legacy section in the palette, but I still want to give you some information about it because you might come across it at some point. Because when you're working with different Android developers in the future, which you will be doing, you're going to need to use, well, you may need to use a relative layout. At least you may need to know something about it. Anyway, that's enough of an explanation. Let's just examine it quickly. So components are placed by each other's position in the relative layout. I'm going to add two buttons to show you how this relative layout works. You see these two buttons take their place on top of each other because we haven't given them any position, right? So I'm going to change the first button text to be capital letter A, and its ID will be lowercase a. For the second button, I will change its text to be capital letter B, and its ID will be lowercase b. Now I'm going to add this to the XML site. I'm going to find the first button and I'll add new XML code. And this code is layout center horizontal equals true. So now button A takes the place center of the row. I'm going to add another code line. This time layout center vertical equals true. Look at that. The A button now takes a place in the center of the screen. Now I'm going to give a place to the B button in relation to or relative to button A. I'll add a new line of XML code for button B. This is layout below. And after choosing this code, we need to write the ID of that button according to which button we will position. And since we will position the B button according to the A button, I'm just writing the ID of button A, which is lowercase a right here. Now, button B will take its place under button A. Now, if I should want button B in alignment with button A, I should add a new line of code. So this code has got to be layout center horizontal true. Now button B is under button A. If I want to put button B above button A, I should write layout above ID A, small letter. See that? Now button B is above button A. So you see, with the relative layout, all the components take their place by each other's position. Now, let's move on to the table layout. So let me just delete these buttons, open up the XML side, and I'll write table layout instead of relative. Okay, so now our main layout is table. In this table layout, components take a place in a table position, right? So in the table layout, there are rows and columns. Also, we need to add rows to this table layout. I'm going to add 3 rows. You can find the table row component in the layout section. Okay, so I will go ahead and add a second row, and then I'm going to add a third row. So after that, I will add 3 buttons for each row. I'll drag and drop the button component from the palette to the component tree. So we've got 3 buttons in this first table row, right? Now I want to also add 3 buttons in the second row. And then lastly, I'm going to add 3 buttons under the third row. All right, so you see this, we now have 9 buttons on the table layout in a table position. So where can we use this table layout? For example, if I want to design a calculator, well, you can use a table layout. So in fact, let's just write some numbers in the text of the buttons as if we are designing a calculator. So I'll write 1 in the text of the first button, 2 for the second, 3 on the third. So see that? This way I can quickly change the text of all the buttons. Write 9, text of the last button, and as you can see, this design can be used for a calculator app. All right, so that's pretty much it for layouts that we're going to be using while we're developing applications together. Of course, in the next lesson, we're going to learn that constraint layout I promised you. So we're going to take a short break here. I'll see you in the next one. Well, hello, everyone. I hope you're enjoying this. So now we're going to talk about this constraint layout. Now, I've mentioned it a few times, but I didn't give you much information. Wanted to leave you hanging, right? Suspense, it's the name of the game. In any event, this whole video is going to be on the constraint layout. Now, to give you a bit of a background, constraint layout appeared with Android 3.0. The constraint layout is an advanced model of the relative layout, right? You remember the relative layout, right? The components can take their own place, according to each other's positions. But there could be problems with different screen sizes. So we're not going to be able to get the full performance for different screen sizes in our app with using a relative layout. But that's why they've come out with the constraint layout. So we're not going to have those types of problems anymore. We can just create. In a constraint layout, components will take their place according to each other's positions and screen edges. So these features solve most of the problems and give a flexibility in ways that you could not imagine before in order to create views for your applications. Now, the constraint layout is a main layout in Android Studio 3.0 and higher. So just make sure that you are aware of what version you're running. And that's why we do the versioning in the beginning. All right. So let's go ahead and go to Android Studio and have a look at how constraint layout works in practice. All right, my friends, I have created a new project for this lesson, and I named this project Constraint Layout. See how clear and understandable that naming convention is? So now, you know how to create a project in Android Studio, right? So go ahead and do that. I'm not going to use up any more time, but just so that you're aware, I created a new project before the lesson. So you can go ahead and create a new project or continue on the project that we created in the previous lesson. It's up to you. It doesn't really matter. I just want to get you in the habit of creating a new project. All right. So I want to show you something now. As you can see, when we create a new project or activity, Android Studio automatically determines the main layout in the design area. And what's it going to be? Yes, constraint layout. So why, oh why, does Android Studio take the constraint layout as a basic default? Well, for some of the reasons I was explaining earlier, constraint layout is way more useful for the different screen sizes. Of course, you can choose whatever layout you want to work on, but if you learn how to work with constraint layout, there's probably very little chance that you're going to want to work with any of the other layouts, to be honest. Also, it depends upon what type of application you're going to develop, but you get the meaning. So anyway, I'm going to add a new button to the design area. When I add this button to the design area, the Android Studio gives me a warning. This view is not constrained. That means when I add a component to the design area, I need to give it a constraint value. So if I run this application, this button will take the 0, 0 position. You follow? So let's run the application, see where this button takes its position. So to run this app, I just click the Run button that represents right here with the green triangle. So I put this button here, but will it stay in the same position? Boom. So as you can see, when the application's open, the button went to the 0, 0 position. Now, the reason for this, I didn't define constraints for this button. So doesn't that lead you to ask the question, well, how do I define constraints? Yes, my friends, in the constraint layout, we have to give at least 2 positions, vertically and horizontally, for every item. So I do it like this. For example, let's say I want to give a position for the left side. I will click the left side of the button and drag it to the left edge of the screen. So this gives its position horizontally. Or we could also use the constraint widget section in the attributes section. For example, to give the button component a constraint value in the vertical plane, just click on the plus icon here. Now this button is bonded to both sides. Now I could just drag this button wherever I want. So when I drop it here, it's going to take its position from the top 180 dp and left 132 dp. You see how that works? Again, you can see these values in the constraint widget section. You can also specify the constraint values here. For example, let's set the distance of the button from the top of the screen to 200 dp. Make the distance from the left side 100. So let's run it again and see what will happen. Application opens, and there you see it takes its position just like we defined. Now also, I can put this button in the center position. All I got to do is right-click this button, choose Center Horizontally or Vertically. I'll choose horizontally, but it, of course, doesn't take the center position because I need to make the constraint 0 that I gave before. So for this, I set the constraint value to 0 from the constraint widget section, right? And then after I delete the constraint, boom, it takes the center position. So let me show you something else. So I'm going to delete the constraint on the vertical plane. Now the button currently only has constraint values in the horizontal plane. Notice, if you will, the Android Studio gives me a warning. Because if I run the application like this, the button's going to jump to 0 vertically. In fact, let's run it again. See how the button takes its place center horizontally, but takes the 0 position vertically? Now, if I right-click again on this button and choose center vertically, it's going to take the center position. All right, so let's run it again. And there you go. It's in the center now. So how can I delete these constraints? Yeah, there's a few different ways to do it. But for now, I just want to show you 3. First, you've got to select the constraint that you want to delete. Press the delete key on the keyboard. That might have occurred to you. But secondly, when you go to the constraint widget section, you have to hover over this circular icon representing the constraint that you want to delete. Then just click on the X icon. Cool. So the third way is you can do this on the XML side. If you delete all the lines of code that occur when you give a constraint here, the constraints you added to the component will be deleted. So you can use, well, any of these 3 different ways, depending upon where you're at. So now I will add constraints for all of the sides. All right, left, right, up, and down. There is also a quick way to delete all of these constraints. So you see there's an icon here. When I click this icon and click yes, it'll delete all of the constraints. Now I will give 2 side boundings. After I bound it, I can drag it everywhere like this. It's easy, right? Let's add another component. I will add a text view. I will put this text view here. So now we have 1 button and 1 text view. I gave constraints for the button, but I didn't give any for the text view. So if I run the application, text view is going to jump to 0, 0. You can see that here, text view is in the start position. And I can give constraints to this text view horizontally and vertically like this. Now let me show you another way. I can give constraints to this text view according to the button. So let me just delete this from here. And I will bound this text view to the button. Now, the text view will keep the distance from the button. Can you tell me what the advantage of this would be? Well, when the application runs in the different screen sizes, the position is going to be kept. So when I drag the button somewhere else, well, the text view is going to follow it. Text view takes its position according to the button. All right, so now I want to show you how this design is going to look in different screen sizes. So you can change screen types from here. For example, I will use 5 ink, 1080 by 1920, 420 DPI pixels. All right, so I want to change the 5.5 ink screen size, and look how my design will be seen. All right, so you can see here, even if I change the screen size, it'll keep its distance. If I choose a tablet screen, it'll be seen like this. You can see here, constraint layout keeps the position of everything in the different screen sizes, so you don't have to think about it. Oh, and also, if I click constraint layout and click the clear all constraints icon here, well, it's going to delete all the constraints. So now if I run this application, the button and the text view will jump back to 0, 0. You can see it here, text view is behind the button. So let me just add another text view. Right, so now we have 1 button, 2 text views, and all of them are in different positions. I didn't give any constraints. So if I run this design, all of them are going to jump to the start position. Now, I'll show you an easy way to give some constraints altogether. There is a button here, kind of looks like a magic stick. So if I click on this button, the Android Studio will take care of all the constraints automatically. So I don't need to figure it out all by myself. So let's run it again and see what's going to happen. And as you can see here, everything is in the same place. Constraint layout made the design itself, boom, automatic. So you're just going to put everything wherever you want and click the magic button. Then after that, constraint layout will do everything just as if you made it yourself. Tastes just as good as if it was in your own kitchen. Anyway, it's enough for this video. All right, so while we're developing an application, you can use any of the layouts that you want for your design. I've showed you some of the things that you can do, but you can also use more than one layout in the design area. It just totally depends on the project that you want to develop, right? So in the following lessons, we're going to use layouts practically. So I'm sure that you're going to understand it even better. We will take a short break here, and I'll see you in the next video. All right. Hello, everyone. So we're going to talk about text views in this video. We've done components on Android Studio. In the last video, we mentioned layouts. We will now talk about Android components to place on these layouts, all right? And one of them happens to be text view. So yeah, what is text view? You might guess, but it's basically a component to show text to the users. Now, you can use text views as a label or to print some results on the screen or print some notifications on the screen, all kinds of different things. Text views can be used in a lot of different areas. It's probably the most commonly used component, so let's get used to it, all right? Go to Android Studio, and we will explore text views while we practice. So let's just create a new project, and I'll explain text view components in this new project. To do that, I'll choose File, New Project Options to create a new project. Choose the empty activity from this window, click Next. And from this window, we can configure the project. So first off, I want to name this project Text Views. I'm not changing the project package name. The file path is where the project will be saved, just like we had it before. Programming language will be Kotlin. Minimum SDK can be 23. All right, so we create the project just by clicking the Finish button. Of course, you could continue with your previous project, but since I'm going to be sharing with you all the different processes that we've done, I just want to explain them through as many different projects as possible. In any event, project is now created. So go ahead and close the previous project, unless that's the one that you're using, and I will just choose File, Close Project as my option. All right, so let's have a look at this text view component through our new project. I'll open up the design area, the activity man.xml file. So first, let's turn the design area into a real phone screen. So for this, I just click on this eye icon up here and select the Show System UI option. Now I'm going to delete the text view component from the design area because we're going to do everything together. All right? Okay. So we can add text views in two different ways for our Android application. First one is the drag and drop method from the palette, just like this. Just drag the text view and drop it under the constraint layout. Now, by using the drag and drop method, you can drop components directly into the design area or into the component tree, as you've seen me do before. All right, so now we have a text view, and its text is also text view. So we can change this text whenever we want to. So this was the first way. Also, there's another way, always. So I'm just going to delete this text view and create a new one using XML code. So that means I'm just going to go over here to the XML side by clicking the split or code option at the top right of the page. Now, if you do select the split option, you can view the XML and design area together. All right, cool. So now I'm going to add a text view inside the constraint layout. So constraint layout must have a body. And for this, we must close the constraint layout's tags. That way we can write code in it. So I'm deleting / and greater than from here. I press the Shift and less than keys on the keyboard together. And as you can see, we have closed the tags of the constraint layout. But this time, we can write different XML codes in it. So we can actually add different components. Now let's add the text view component. To add a component using XML code, you got to first create a new tag for the component that you're going to add. So to do that, I'll press the less than key on the keyboard. Now we've got to write the name of the component that we're going to add. So when I start typing text view here, the code editor offers me the text view component, just like that. So I'll select it, press enter on the keyboard. When we add a component, we need to specify its exact width and height. So for now, we'll make the width and height wrap content for now. And let's close the tag of the text view component. And since the text view component will not have a body, I close the tag by pressing the slash key on the keyboard. All right. Now we have a text view here, but we don't see it. Why is that? Well, just because we didn't write any text. So I'm going to add a new line inside the text view using XML code. Now to add a feature to the components using XML code, you just type the name of the feature you want to add, and then choose the most suitable feature from the features suggested to you by the code editor. So in this example, I'm just going to add text to the text view component. And that's why I'll just write text here. And just like that, as you can see, the code editor offers many features related to text. So that's cool. So from here, I'll just select Android text as my feature, press enter. Okay, so now we need to define the text that we're going to add. And as tradition dictates, I just write hello world as the text of the text view component. Now, whatever I write inside of quotation marks, the text of the text view will be what I write. You follow? So now we have a text view on the design area, and the text of the text view is hello world. I want you to notice something else. We've set the width and the height of the text view component wrap content. So setting a text view's size to wrap content is going to force it to expand only far enough to contain the values that it has. You follow? Just like anywhere else. So if I add new words to the text, such as to the human, the size of the text view will be bigger. If I change to a bigger number size of the text inside the text view, well, the height of the text view will also be bigger. And if I were to change the text size to 40, the text view size gets bigger. If I change text to 20, the text view size gets smaller. Now, on the other hand, I can choose the width of the text view as a match parent. So if I write match parent here, the text view component will cover all of the device screen from left to right. Now also when I write match parent for the layout height, text view component will cover all of the device screen from top to bottom. So now I'll choose wrap content for layout height. And also we could give numerical values for height and width. So I'm going to give 150 for width, 75 for height. Also, I'm going to drag the text view to the center of the screen. Now, of course, since our main layout is the constraint layout, we do need to determine the constraint values of the components we add to the design area. Otherwise, when we run the application, components are going to move right back to the 0 point of the screen. And that is, by the way, up here, the upper left corner. So when I click Text View, I can see the attribute section on the right side of Android Studio. I can also see the operations I can do on the text view here. So for example, I can change the layout margin here. When I change the layout margin, the text view position will change on the screen. If I write 250 up in here, well, the text view's position is going to go down. If I write 150, I'll go up. I can give numbers from here for left, right, top, and bottom. The layout margin property defines a position of the text view on the design area. But also, there's another attribute I want to show you. It's called padding. And padding basically defines text position inside of the text view, right? So let's say I write 25 dp for the padding start attribute. Well, the text is going to go 25 dp from left to right. If I were to write 10 for the padding top attribute, of course, the text is going to go 10 dp from top to bottom. Also, we can change the text size using the attribute section, right? So if I choose 24, the text is going to get bigger. When I choose 14, the text is going to be smaller, all right? Now, by the way, all the changes that we've made in the attribute section will be added in the background as XML code. Of course, if you want, you can write XML code to do some operations, or you can use the attribute section. So let's see what we can do in the attribute section. We can change the background color from here. So why don't we choose purple 700 as a background color? Now see how the background of the text view has changed. Using this property, you can change the background color of the components. Here's something. It's called gravity here. You can define text position automatically inside the text view from here. So I'll choose this center, and text will take the center position vertically and horizontally. But if I choose this, well, I need to change the padding property to 0. See, so we can change the text color from here. For example, I'll choose white, and text color will be white. We can do a lot of operations from here. But also, we can do these operations on the main activity.kt file. But before we start working with Kotlin code, we do need to give an ID to this text view. In order for the text view component to be recognized in Kotlin, we got to define its ID here. So I will give text example as its ID. So now our ID of text view is text example, and the text of the text view is hello world to the human. All right, now let's go over to the Kotlin side. Don't be shy. We're going to start to write code now. That's why I want you to follow the lesson pretty carefully from now on. All right. So if you notice, there is a class called main activity, right? And inside this class, there is a function called onCreate. Now this onCreate function is also created automatically when we create an activity. So what do you do with the onCreate function? We're going to talk about this function in the lifecycle lesson, but for now, I just want to explain it briefly, all right? So basically in Kotlin, every activity has a lifecycle. That is, until you open and close an application, some threads, in other words, functions, are going to be called. The first 3 of these functions is the onCreate function. In the onCreate function, our activity is still under creation, and the user wouldn't be able to see at this stage. But we also want the codes that we write to be ready until the activity is shown to the user, right? Therefore, we generally write our codes inside the onCreate function. Now, naturally, there are many more functions in the lifecycle, right? And we're going to learn about all of that in detail in the lifecycle lesson. But for now, it's enough to just know that the onCreate function is the very first function in the activity lifecycle. And we usually write our code inside of this function. Yeah? All right. So that's a short explanation. Let's just figure out how we can access the text view component in the design area. So above the onCreate function, inside the main activity class, we're going to create a variable from the text view class. That's why I'm typing var here, all right? The keyword var represents variable. All right, so now we need to just give it a name to this object that we're going to create. I'm going to use this name on the Kotlin side, so you can give it a name, whatever you want. I'm going to call it myText, and now I'll just put colon and write text view here. All right, so when we type text view, see how the code editor offers us text view, one of the Android widgets? Yeah, so from here, you can just select text view and press enter. But now, at this point in time, I do want to tell you one more thing, just to squeeze it in. In order to use different packages in your project, that is to use this text view component here, well, this package must be imported into your project. Now, an import, I think you might have heard this for the first time. Did I just say import it into the project? Well, yeah, because you have to indicate to the code editor that you're going to be using this package. Because there are just, well, thousands of packages that can be used in Android, and we really only should be using the packages that we need. So if there were no imports, we would just have to define thousands of packages here, which, as you might imagine, that could get rather complicated quickly. So I just want to show you the import process. Not going to choose the text view component that the code editor recommends. As you can see, Android Studio is going to say, hey, wait a minute. So we have to import the text view class. Of course, there are different ways of importing, but the first one is to select the text view suggested by the code editor and press enter. The second one is to move your mouse over the text view and select the import option from there. Third, select the More Actions option here and select the import option from the pop-up. Fourth, if there is a red light bulb that appears on the left, well, just go ahead and click on that light bulb and select the import option. Right? So finally, you need to click on the text view expression here and then press the Alt and Enter keys on the keyboard. Cool? So when you do any of these operations, you can see the imported packages in the import section right here. Yeah, so that's pretty much the import process. You do it as you go. That's cool. But look at this. We're still getting a warning. Well, why is that? I did everything like you said. Well, because in Kotlin programming, if we're going to create a variable within the class, we must initialize this variable. But we sometimes want to initialize variables later. So we'll just initialize variables later, right? So in this particular case, we've got two different options in this example. The first is to use the late init keyword. When you use late init as your keyword, the code editor understands that you're going to define the variable later. So it no longer throws an error. The second is a method that we use very frequently. That is to assign a null value to the variable initially. So for this, all you have to do is write equals null after placing a question mark just to the right of the text view class. All right? Now we will usually use the late init when describing components. Yeah? So we created a variable from the TextView class. So now let's match this variable to the TextView component in the design area. And as always, there are two different ways to do this. First one is to use the find view by ID function. The second one is to use view binding. Now, I would like to mention here view binding. That's going to be a whole separate lesson in the future, so don't get too hung up on that. Not going to use that for now. It's enough to match the variable we defined here with a component in the design area just to first write the variable name. After the equal sign, we use the find view by ID function. Yeah, so this function uses the ID of the component in the design area to match the variable that we defined here. So we've got to write the ID of the component in the design area in parentheses. All right, so for this, I'm writing r.id.textExample here. The R will represent the resources folder in the project directory. The ID represents the IDs that we defined for each component, right? And finally, we select the component's ID with whichever component that we're going to match the variable with. Very cool. So now we assign the TextView component to the myText variable we created on the Kotlin side. Now, I can do all the operations I have done on the XML side here, but how am I going to do that? Well, let's see what happens if I write myText here. I will add a dot here. After the dot, I can see all the operations automatically. That's pretty cool, huh? Look at that. There are plenty of operations here I can choose from. For example, let's say I choose set text color. So I can choose the color writing color.black. Boom. When I write this code, nothing's changed on the XML side. Changes will be applied when I run this application on the device. So let's have a look at that. Let's run the app. And I'll click Run after the device opens, and I can see changes on the application. Of course, it might take a little time to come online. And there you go. Now you can see the text color is black. Now also, I can change the text of this text view. So for this, just use the set text function or just the text option. If we use the set text function, we've got to write the new text that I want to change inside the parentheses. So I'm going to write, this is an example. But you got to be careful. You need to write the text inside the quotation mark. You see that? Because this is a string expression after all. Now, if we use the .text option, we write the new text after the equal sign. Also, we must write the new text between the double quotes. Okay? So I'm going to run it again. And there you go. You see the text change. Now, in addition, we can add a feature to the text view. If we click on text view, we can start an operation. For example, when I click on text view, we can open a new activity, or we can change text size or text color. Why don't we give it a shot? How are we going to do this? So just add a click listener to this text view. I'm going to write myText.set on click listener. So notice there are two set on click listener properties here. You can choose both, but I usually choose the option with curly braces next to it. And if you select this, press enter, you will add the click feature to the text view component. All right, so now I'm going to write new code inside the curly braces. So these codes will work only when I click on the text view. Follow? So I will write inside the curly braces, myText.setTextColor. Inside the parentheses, I write color.white. So I'm going to click run again. And after a little while, the device is up and running. And you can see here, there are no changes to the text view. After I click on the text view, the code will work and the text color will be white. All right, so let's change the background color of the text view. So I'm going to write my text.set background color. Inside the parentheses, I write color.black. I'm going to click run again. And now you can see after I click text view, the text color will be white and the background of the text view is going to be black. Now we can do more and more and more operations here, but I think that's enough for now. There are many more other components that we need to learn before we get too involved with all the detailed options. So I want to see you in the next video. Well, hello everyone. So today we're going to talk about everybody's favorite subject, and that is buttons. Buttons are Android components, right? So when you click on buttons, buttons will do some sort of specific operation. Buttons are probably one of the most useful components. If I wanted to list you the top 3 most used components, I would say buttons, text views, and edit text. Give you some context. In the last video, we spoke about text views. This video, we're going to talk about buttons, and then guess what? Next time, we're going to talk about edit text. So let's just go to Android Studio without using any more time. So I've created a new project for this lesson, and the name of this project is, guess what? Buttons. You could also create a new project or continue on the project that we created in the previous lesson, though. Anyway, let's move the XML code of the text view component that we created in the previous lesson to the design area of this project. So for this, in the previous project, I open the XML code. I'm selecting and copying the codes that belong to the text view component here. Now I'm just going to paste these codes into the constraint layout component in our new project. All right? You can add a new text view component, but so that the duration of our lesson isn't too horribly long, I'm going to use the design that I created in the previous lesson as well. All right? So, yeah. Now, let's get into the button component. So we're going to add a new button to this project. Now, you know before that we can create a new button 2 different ways. First one is drag and drop. So I'll select the button component from the palette, drag it to the component tree or to the design area directly. Okay, so as you can see, I added a new button. I can drag it wherever I want as well because I'm using the constraint layout. All right, so what about the second way? Well, you got to add a new button using XML code. It's pretty simple, so we'll add a second button using XML code. Go to the XML side, and you can see right here the XML code that I added a button, right? Okay, so I'm going to add another button. Inside the constraint layout tags, I'll open a new tag by pressing the less than key on the keyboard. I write button here. I select the button and press enter. And look at that. As you can see, the Android Studio will autocomplete. So I'm going to need to define height and width. I'm going to choose match parent for 2 of them. You can see here that we've got a second button, but it covered the full screen. So I'm going to change the height to wrap content. All right. Now the button covers the screen just from the left to the right. So we need to give a text to this button. So I'm going to write here text and select the Android text option. Inside the quotation marks, I'm going to write button 2 as my text. And now you can see button and button 2 in the design area. All right, so let's change the width of button 2 to be wrap content. Very good, so now we've got 2 buttons. The first one has been created with the drag and drop method. The second one using XML code, so you can see either way is great. Of course, since our main layout is the constraint layout, we do need to determine the constraint values of the components that we add to the design area. See, otherwise, when we run the application, the components will move to the 0, 0 point of the screen, that is to the upper left-hand corner. But this time, I will put the constraint values to be automatic. So for this, I'll select the constraint layout, click the Infer Constraint option, and that is represented with the magic stick. Don't you love a magic stick? All right. So we can do a lot of operations on these buttons. We can do those operations in the attribute section. We can define height and width here. We can specify the layout margin from here. We could also define padding here. I can change the text of the button from here. I will write here, do your magic. And you can see the button got bigger because the button width is set to wrap content. So when text gets longer, the button will get bigger just to accommodate that text. All right. Now also I can change the background color of the button using the background tint property. So let me just choose a color from here and the button color will change. Now also I can choose clickable or not. You can think, why did I put a button in the project and not make it at all clickable? So, well, if I do not click on this button, why did I put a button here? Well, this actually brings us to an important point, because you can do regulation on your project and you can do your button to be clickable after some operations, but before those particular operations, the button would not be clickable. You follow? Let me give you an example. Let's say that you design a game and inside the game there is a next section button, but you don't want the player to pass over to the next section before getting to a specific score. So you could specify that after the player collects whatever that score might be, well, the next section button could then be clickable. So then the player could go on to the next level after making that required score. All right. So we could also change the text color from here. Change the text size, of course, from here. Oh, also another important thing, we can make our button visible or invisible. Yeah. If I choose the invisible, well, the button's not going to be seen. So this feature can be used, well, for the same purpose that I mentioned about being clickable or not clickable. Obviously, context will dictate whether you use which. All right, so we're going to need to give an ID to these buttons to make sure they work on the Kotlin side. Android Studio gave this button an ID. Now, it is button. And of course, you could change it if you want. I am going to change it, and I'm going to make the ID do magic. Yeah. So now the ID of this button is do magic, and the text of this button is do your magic. All right. So let's give an ID for the second button, and I'll write my button here. And now I will need to define the buttons and the text view component in the design area. So first I'll define the buttons. I'll write late init var here. And of course I'll need to give a name to this button to work on this button. So I'll write do magic, but you can put in whatever name that you want. After putting the colon, I'll write button. Select the button option that is offered to us by the code editor. And that way we'll import the button class in our project automatically. And the same way, I'll just define the second button. I'll write late init var my button. After the colon, I'll write button, and then we can define the text view component. So I'll write late init var my text. And then after dropping in a colon, I'll write text view and select the text view option that is offered to us by the code editor. Very generous. And that way we import the text view class into our project automatically. Pretty awesome. Now also I'm going to need to match these components with their IDs inside the onCreate function. All right, so for that I will write doMagic equals find view by ID. After I write find view by ID, I will write inside parentheses r.id.doMagic, because the ID of my first button was doMagic, right? All right, so for the second button, I'm going to write my button equals find view by ID. And after I write find view by ID, I will write inside parentheses r.id.myButton. For the text view, I will write my text equals find view by ID. After I write find view by ID, I will write inside the parentheses r.id.textExample. All right, so now I've defined the components on the Kotlin side. I can do everything in here. And I'll write doMagic, and after the dot, look at all the operations I can do. I'm going to add a click listener and work inside this method. So I'm going to write set on click listener and select this option and press enter. So after that, everything that I write inside the curly braces will be executed when I click on the button, right? So I'm going to write doMagic.set background color. And inside the parenthesis, I will write color.black. So this code's going to change the background color of the button after I click the button. All right, so let's run that and let's watch it work. All right, so you see that it's magic. Well, okay, so you see that it's working anyway. We can do some operations on the other components from here as well. For example, we can change the text of the text view from here. So I'm going to write my text.setText. And inside the quotation marks, I'll write, I have done my magic. And let's run the code. So you see when I click on the button, the text of the text view changes. Also, I can, well, make that invisible. So here I'm going to write my text dot is visible. After the equal signs, I write false. All right, so let's run the app. So here the application's open. Click the doMagic button, text view and button 2 component disappears. Also, the doMagic button moved upwards. Whoa! Did you expect that? Well, I did. Why is that though? This is because the constraints we define in the design area. If you can remember way back, we automatically define the constraint values of the components, right? So for this reason, the top constraint of the doMagic button was pinned with the bottom constraint of the text view component. So when the text view component became invisible, the position of the other components changed too, all right? So now I'm just going to delete the constraint of the doMagic button, pin it to the bottom of the screen, and let's go back and test the app out one more time. So the application opens. When I click on the doMagic button, the text view gets, well, disappears. So now I'm going to do the invisible doMagic button itself. So for this, I'll write doMagic.isVisible. After the equal sign, I'll write false. Now let's run that code. The application opens. Now I click the Do Magic button, and as you can see, the button and text view are invisible now. So you can see here, there's another button, but when I click it, it's not working because we didn't write any code for this button. So if you want to, let's go ahead and make the button and text view components visible when you press this button. So first, we'll add a click listener to the button. Here I'm just typing my button dot set on click listener. Inside the curly braces, I'll write my text dot is visible equals true. Similarly, I can write do magic dot is visible. After equal sign, I'll write true. All right. So we'll run the application again. And first of all, I'll click on the Do Magic button. As you can see, the button and the text view are all invisible. So now let's click on this button, and there you go. The components are now visible. So we can do a lot, right? We can do many more things here, but I do want to move on to another topic that includes buttons, because the design of the buttons is almost as important as its code. All right. So because of this, you really do need to learn the different types of button designs. Let's say, for example, you would want to shape a button into an oval, or maybe circular, or make it rectangle. So when we want to change the button design, we do need to create a new XML file under the drawable folder. All right, so I'm just going to right-click on the drawable folder. After that, I will choose New Drawable Resources File. And all this will open a new window. And I need to give a name to this new XML file, right? So I'm going to name it button_shape. All right. So now that we have this new XML file and its name is button shape, there are some codes in here. And these codes are about when we click on the button, what its design will be. All right. I'm going to delete these codes. I'm not even going to worry about it right now. I will change its shape. So now I'm going to define the shape by writing Android shape oval. Also, I need to choose a color for this button. So for this, I'm going to define a solid color here. I'll open up a new tag, write solid, and press the slash key on the keyboard, closes the tag, right? So now I can define the color of the shape. And I'll write the color and select the Android color option. I will choose the color teal 700, but you can, of course, choose whatever color you want. So we've defined the button shape, but has anything changed on the main activity XML page? Well, we do need to set it as a background because we created the button shape XML. So how do I accomplish that? I'm going to go to the XML side of the activity main page, and I will add the background property. So I'm going to select the button shape XML file under the drawable folder that we created before. Now notice that the shape of the button has changed, but its color has not. So for this reason, we change the app background tint property to null. Otherwise, the shape of the button will change, but its background color will not. All right. Now you see that the button has taken its oval shape, but we define width and height wrap content. We need to change that too. I'll change both of them to 150. All right, so the button takes the shape of a ring, and you could make it square or rectangular. That, my friends, is up to you. But now you see what's going on. All right. So sure enough, that's how you use button components in Android Studio. And really, I think that's enough for this video, don't you? So let's take a little break, and I'll see you in the next video. Hello, everyone. All right, welcome to the next video. So we're going to talk about edit texts in this video. So edit texts are Android components, and these are basically used to get data from the users. You can see edit text in many Android applications to get data from the user, such as the name, the last name, the password, address, whatever that might be. Now, there are different types of edit text, and we're going to see these different types in this video and practice with them. So let's go to Android Studio. All right, so naturally, I created a new project for this lesson. The name of this project is Edit Text. All right, so you can also create a new project, and you could also continue from the previous project, whatever you want. You could probably be teaching this course already, right? All right, slow down, not so fast. That's okay. So let's have a look. You can see Edit Text here on the left side of Android Studio in the palette window. Under the text section, the name is Plain Text. Cool. So under this plain text, there are other types of edit text, such as password input, email input, phone number input, multi-line input, time, date, all these, right? So before we start edit text, we got to change the constraint layout to linear layout. All right, so this way we can learn to work with linear layouts at the same time. So I'm just going to delete constraint layout from the XML side and write linear layout here. Now also, the orientation of this linear layout will be vertical. All right, so now the layout's ready. I'm just going to drag and drop a plain text under the linear layout. So now we've got an edit text. ID of this edit text is edit text person name. And the text of this edit text is name. So when we run this application, users will enter data from here, such as name, right? So let's run it and see what happens. There's the application running. And you can see here users will enter data from here, right? Now, I will delete the word name that we wrote before. I can actually write anything here. Also, I could enter numbers from here too. All right, so let's add another edit text. This time I'm going to add password edit text. Also, I will add numerical password edit text. So numerical edit text, that you can just enter the numerical number from here. And also multi-line edit text. Also, let's increase the height of the multi-line edit text a bit because we're going to write multiple lines in this edit text. All right, so let's run the application with these edit texts and see what happens. So the first one is a standard edit text. You can enter numbers and characters. The second one is password edit text. So when you enter the password in this edit text, numbers and characters not going to be seen, right? You can enter numbers and characters, of course, into the password edit text. You're just not going to see them. That's the nature. So the third one is also password edit text, but users can only enter numbers, not characters. Also, these numbers will not be seen in this type of edit text. Now, the last one is multi-line edit text. Users, of course, can enter more than one line of information in this type of edit text. So I'm going to write in here some text lines just to show you how it works. And you can see here after the first line, the second line continues under the first line. For example, let's say you could use this type of edit text to just bring on some user comments or maybe an address or maybe a complaint if you're so open, that kind of thing. Anyway, in the first one, when the user enters more than one line, after that line is finished, well, the head of the line is not going to be seen. You see how that works? Now, we're not done just yet. We've only placed the edit text in here. We have to take this information and use it somehow. So how do we use it? We're going to do that on the Kotlin side using Kotlin code. All right. So we're going to continue with an example. I'll delete edit text except for the first one. Also, I will add a button and a text view. All right, so we're going to develop an Android application, right? The user will enter the name into the edit text, and after they click the OK button, the name is going to be seen on the text view, right? So I'm going to delete the text of the edit text, but it's not going to be empty. I'm going to add a hint property to this edit text. So the hint is a tip given to the user to understand what the user will write in the edit text, right? So I'm going to write in the hint section, please write your name. All right. So I'll change the text of the button to be OK. I've also deleted the text of the text view. Let's change the design of the application a little bit. So let me do 50 dp, the layout margin, top property, the edit text. Also, I'm going to give some space between the edit text and the button, about 30 dp. And likewise, I will give some space between the button and the text view. And I'm going to do 50 dp, height of text view. Cool. I'm also going to change the width of the edit text. I'm going to give that 200. It's a little small, so I'm going to give it 300, okay? Yeah, that's good. So, yeah, I'm going to change the height of the edit text to 60. And in the same way, I'm going to change the width of the button to 300. Now for the text view, I'm going to do the exact same thing. Okay, so I'm going to place these three components right into the center of the screen horizontally. Now, how do I do that? I first select the linear layout, then I'll go to the gravity property from the attributes section, and I will choose the center horizontally option. So now all the components are placed in the center. And I will add a text on the text view, and let's just call it results. And we might as well also center the text to the text view component. For that, I can just change the gravity property of the text view component to center. And also, I'm going to change the background of the linear layout. Now, from here, you can choose any color you want. I'm going to just choose a color in shades of blue. Yeah, I think that color is the one I was looking for. So after choosing a color, I'm just going to press OK. All right. Oh, so let's change the background of the other components too, huh? So I'm going to choose white for all three components. And first we'll make the background color of the button white. Of course, since the text color of the button is white, the arrow text is not going to be visible. So I got to make the text color be black. All right, so now let's make the background color of the edit text component white. See, so notice now that we changed the background color of the button using the background tint property. Yes? Cool. So for the other components, we use the background property. All right, so finally, I'm going to change the background color of the text view component. Yeah. Whoa, the button's a little big, don't you think? So I'm going to change the width of the button to 200. All right, so now I will give an ID to these components. For the edit text component, I'm going to write edit text name. Button OK, and that's for the button. And text view result is for the text view. Yeah, I think that's going to be okay. So let's run it and have a look on the phone. So yeah, you can see the application is working. You can see the hint here. When I write Arnold here and click OK, Arnold should be seen on the text view instead of result, but the application's not doing this now. Why is that? Well, like I told you earlier, we haven't written the Kotlin code yet, all right? So for that, let's go to the main activity.kt file, and we'll write some code. Yeah. First, I'll define these three components. I'll define edit text. Now, after I write late init var, I need to give a name to this edit text. It can be name, simple as that. So after the colon, when I write edit text and choose from the autocomplete, Android Studio imports the required class android.widget.editText. Cool. Second, I'm going to do the same thing for the button, and I'll make its name OK. Last component, text view, write late init var result colon text view. All right, so now I'm going to assign the XML components that I designed before to these names using the find view by ID function. And that is inside the onCreate method. Now it's all falling into place, right? So here I write name equals find view by ID r.id.edit text name. All right? Second line, OK equals find view by ID r.id.button OK. And just like I did before, result equals find view by ID r.id.result. You with me so far? All right, because so far so good. So I'm just going to add the click listener to the OK button. All right, OK.set on click listener. I'll choose the click listener that's offered to us by the code editor automatically, and then autocomplete will take care of the rest. And I will write code inside curly braces. Cool? So now we can start coding. So first, I have to get the data that the user enters in the edit text. How do I do that? Well, I'll just write in here, name.text.toTheString. So this code will take that text that the user enters in the edit text and then convert it into the string. Okay, so now I want to write this string on the result text view. Follow? But before I do that, I'm going to need to define a string container named username. So I will assign the text that I took from the edit text to this username string. And then because of this, I will write here var username colon string equals name.text.toString. All right, so I can set this username on the text view. I will write here result.setText, and then inside the parentheses, I will write username. Also, you can write this code instead of the setText function. Result.text equals username. Now, I know it's a bit complex. I really hope you understand this part. It is very important. Go back over it if you need to. But basically, I define a container, and its name is the username. Then after that, I took the text the user entered and converted it to a string. And then I assigned this text to the username container, that is, variable. And then lastly, I set this username to the text view. All right? So let's run the application and see how it works. So the application opens. I'm just going to write in here a name and click OK. All right, so as you can see, it works. It takes the name that I wrote in the edit text and writes it to the text view instead of result. Got it? All right. So that's enough for this video. Yeah. Edit text, like I was saying, kind of complex, but you got to master it. So go back over it if you need to. And I will see you in the next video. All right. Hello, everyone. So we're going to talk about image view in this video. Image view is an Android component to display images. Natch, but showing images is very important for an Android application. If you use good photos in your project, your design's going to look wonderful. So because of all this, the usage of the image view component is very important. So why don't we just go to Android Studio and learn image view while we practice. All right. So, we have a project from before, so let's continue to work from this project. The first thing we're going to need to do is add the image that we're going to display in the image view component right here into our project. So I'm sure you remember I was showing you that we add pictures to the drawable folder. That rings a bell. So we're going to do all that right now. You can add images in a couple of different ways. First, you have to right-click on the drawable folder and select Open in Explorer. Then you should move the image that you want to add to the project to the drawable folder from here. All right, so that's the first method. You already know that method. So now let's have a look at the second method. So this way, you got to copy the image that you want to add to the project. After that, you just right-click on the drawable folder and select the Paste option. And from here, you just select the drawable folder, not the drawable v24 folder. And then also, the name of the picture that you're going to add to the drawable folder has to be lowercase letters. And if it's longer than one word, no spaces whatsoever. You can, of course, use underscores to separate words, so that's not a problem. Otherwise, you will get an error. You just can't forget that, that's all. Unless you like getting errors, I don't know. Anyway, and there you see it. Using both methods, you can add any images that you want into your project. So, now that we've done that, we can learn about the image view component. All right, so adding an image view to this project. First of all, where is image view? Well, it is inside the palette window, and it's under the widgets on the left-hand side of Android Studio. So I am going to drag the image view and drop it under the linear layout. So that puts it as the first component. This is a linear layout and its orientation is vertical. So because of this, all the components are going to take a place from top to bottom. So when I drop the image view, a new window opens up. And this window is the resources window. So here I need to choose a picture for this image view. See how that works. I'm going to select the image that I just added to the project, click OK. So now I can see this picture in the design area, but there is a problem. Do you see it? Well, because I cannot see other components. All right. Now, what's the reason for that? The height of the image view, wrap content, also the size of my image, way too big. So when the image view uses wrap content for height, the image covers all the screen from top to bottom. So I need to change the layout height and layout width to 300. Okay, so now you can see all the components in the design area. Also, if you notice, and when you pay attention to this, okay, so the image view component is in the center of the screen horizontally because I choose the layout gravity property to center horizontal. You remember that for this linear layout. Last video. And that way all the components are placed center of the screen horizontally. So if you look at it carefully, you can see that the image is placed inside the center of the image view. Now, if you want your image to cover all the image view component, well, you should choose the size of the image exactly the same as the image view, right? You know what I'm saying, right? I'll give you an example. If the size of your image view is 300 by 300, the size of your image should also be 300 by 300, or vice versa, whatever. But we could also do some arrangements within the image view. So I'm going to go to the scale type property, and that's in the attribute section, and choose from here a few options. Now, if I were to choose the fit start, the image is going to take the place from the start position. If I choose the fit center, image will be seen in the center. And if I choose the fit end option, it's going to take its place from the end position. Now, what happens if I choose fit XY? Well, the image is going to cover all of the image view, but the image will be enlarged and it might not look very good. So because of this, the fit center option is often a very good option, but naturally it's up to you and what the image is. All right. So these are only some of the things that we can do on the design page. We can also do a few things on the Kotlin side using Kotlin code. But before going to the Kotlin side, I will need to give an ID to this image view, right? So I'm going to give the image example as the ID. Okay, so what can I do here? For example, when I click on the OK button, the image in the image view component is going to change. Right? So I will see another image inside the image view. So how do I do that? Well, we'll go to the main activity.kt file and start there, okay? So first, I'll define this image view on the Kotlin side. I need to write late init var image : image view. I'll give image as its name. And you can, of course, name it whatever you want. But now I need to define its ID inside the onCreate method. And I'll write image equals find view by ID. And inside the parenthesis, r.id.image example. So now I can do every operation on the image view using the image word, right? So I'll write operation codes inside the click listener of the OK button. Now, let's turn the codes that we wrote in the previous lesson into a comment line. So if you just put a double slash at the beginning of the code, you will only comment out a single line. If you use slash and the asterisk, you can also comment out multiple lines. Okay, so now we can write the necessary code. I'm going to write image.setImageResource, and this function is used to change an image in the image view. But before I continue with that, I do need to do one more thing. How about a second image to my project? So I can right-click on the drawable folder on the left side of Android Studio and choose Open in Explorer. After that, the drawable folder is opened. Inside the drawable folder, I have one picture. Its name is first image. So I can add a new image to this folder and make its name second image. All right. That way, when I close this folder, I can see the second image in my project. So now I can call this image and I will write inside the parenthesis r.drawable.secondImage. All right, so now that everything is okay, when I click on that OK button, the image is going to change to the second image. So let's run it and see how it works. Yeah, so the application opens. When I click the OK button, the image changes, just like that. All right, so that gives you an example of how it works, and that'll work like that for a variety of operations. But it's enough for this video. So I want to see you in the next video. All right? We're going to do some other stuff. See you on the other side. All right, hello everyone. I want to talk to you about the checkbox. So the checkbox is a different type of component in Android Studio. It's a kind of a button. It's going to take two positions, checked or unchecked, and it's a frequently used component when you're developing Android applications. For example, when we develop a survey application or a note-taking application, we can use checkboxes. So we'll go to Android Studio and see it in practice and learn a few things at the same time. All right, my friends, so we can create a new project for this lesson. And how do you create a new project? Just click the New Project button here. And from this page, I can select the Empty Activity option from Tablet and Phone section and press on the Next button. We will configure our project from this page. I'll set the name of the project to be Checkbox. Now, I'm not going to change the project package name or the file path. The programming language will be Kotlin. Minimum SDK level can be 23, so that's all good. And we can create our project just by clicking on the Finish button. All right, so our project is now being created. And of course, it could take a little while. But please, again, let me just repeat that don't do anything before the project's fully created, all right? You might get some errors. You might not, but you might. And it's not necessarily consistent either. But that way, yes, you'll be error-free. Okay, my friends, as you can see, our project's now created. So we can open up the activity main.xml file. And we can just close the project directory. Now, first of all, you see the eye icon. We're going to go up here and select Show System UI for my options. Now, so our project will basically look like this. Okay, so as you can see, there is a text view in it, and it contains what is your gender. All right, so there are also two checkboxes just below the text view component, male, female. If you want to, you can add others, but we're going to just keep it simple for now. And we'll click the male checkbox, text view. The Your Gender is Male statement will be written. And if we click on the female checkbox, the Your Gender is Female statement will be written. All right, so that's what it looks like, very simply. Let's get started. So first off, why don't we just change the background color to the design area? So I'll choose Constraint Layout from the Component Tree section. Then I select the background property from the Attribute section. And from here, you can choose any color that you want. I'm going to choose a color like this for now. Press the OK button. All right, so now let's edit the text view component in the design area. So I'm going to first delete the bottom constraint. And we can also make this top constraint value 150 dp. And we'll make the width of the text view component 300. And we'll make the height 60. Now let's change the text to the text view component. So here I'm going to write, what is your gender? And let's increase the text size. And I'll make the text size property 24. All right, so let's change the text color to white. And you know what? Let's also change the background color. Now, if you click here, the color palette will open. And here you can choose whatever color you want. I'm just going to choose a color in the red shade family. And finally, we're going to align the text in the text view. So for this, I'm going to use gravity and padding. So I will make the gravity property of the text view component center vertical. And now I do want to leave some space to the left of the text. So for this, I'm going to just change the padding left property to 7. Yeah, that's pretty much okay. So now let's add two checkbox components to the design area. You can find the checkbox component in the button section of the palette. And I can just drag and drop it into the design area, place the checkboxes just below the text view component. And I'll add one more checkbox in the same way. And of course, you could add another few if you need to, right? Okay, so first let's change the text of these checkbox components. Text of the first checkbox will be male, and I'll also make the text of the second checkbox female. And I'm just going to keep it simple for now. I'm going to make the margin start values the same to keep them aligned. And I'll set the margin start value of the first checkbox to 160. And likewise, I can set the margin start value of the second checkbox to 160. Now also, since our main layout is the constraint layout, I got to specify at least one vertical constraint, right? So I'll write the top constraint value of the first checkbox as 20. All right, so I'm going to make the top constraint value of the second box 10. And lastly, we'll increase the text size of the checkboxes. So for the first male checkbox, I'm going to make the text size 20. The second checkbox, I will also make the text size 20. All right, it's rough and ready. I think that design is kind of finished. So finally, I've got to determine the IDs of these components, all right? That way if I didn't do that, right, I wouldn't be able to access the components on the Kotlin side. So I'm going to make the ID of the text view component be text view result. So after typing the ID, I press the Enter key on the keyboard. I can choose the refactor option from this warning window that opens. And then similarly, let's determine the ID of the checkbox components. Let the ID of the first checkbox be checkbox male. And let the ID of the second checkbox be checkbox female. And sure enough, we've now completed this part of the design. So we can now go and open the mainActivity.kt file now. All right, so first of all, I will need to define checkboxes and text view. So I'm going to write here late init var. Now I've got to give a name to this variable, so I'm going to write male. This name is my choice, so you can name it whatever you want. And after the colon, I'm going to write checkbox. And of course, we've got to define the other checkbox. I'll write late init var female colon checkbox. And then lastly, I define the text view. I write late init var result colon text view. Okay, so now I need to assign IDs to these variables. So I will write male equals find view by ID. r.id.checkbox male. And for the second checkbox, female equals find view by ID. r.id.checkbox female. For the text view, result equals find view by ID. r.id.textViewResult. All right, so after that, I'll just add the click listener to the checkboxes. That way, when the user clicks on the checkbox, it's going to do some operations. So I just write in here mail.set on click listener. Now I can write my codes inside the curly braces. And there are two options for the mail checkbox, checked or unchecked. So I'm going to write if mail.isChecked. This will control checkbox is checked or unchecked. If it is checked, it'll return true. If it is unchecked, it will return false. So if it is checked, what's going to happen? I want to write your gender is male on the text view. So I just write in here result.text equals your gender is male. Now, why did I write the result? Because we gave the result to the text view as a name, right? We don't want to say result. So if it is unchecked, I will write again the question. And for this, we need to create an else block. I will write else inside the brackets result.text equals what is your gender? All right, so I'm going to do the same for the female checkbox. female.set onClickListener inside the curly braces. If female is checked, result.text equals your gender is female. If the female is unchecked, result.text equals and question again. What is your gender? All right, so that's it in a nutshell. Let's run it and see what it looks like. So the application opens, and you see if I check the male checkbox, the text of the text view is changing. If I uncheck the male checkbox, the text of the text view is changing to the question again. Cool. If I check the female checkbox, the text of the text view is changing. And if I uncheck the female checkbox, the text of the text view is changing the question again. All right? Now, I wonder if you notice, we could have a problem here. What if I were to check both? Now, we're not obviously getting into biology here, but I do want to ask for this example. I'm not going to be able to let the user check both of them, so how am I going to prevent that? Well, we will need to write some extra code. So I'm going to do this in the if block. So follow along. If male is checked, female must be unchecked. So I will write female dot is checked equals false. So this code defines the position of the text box. If it is true, the text box will be checked. If it is false, the checkbox will be unchecked. Right? You follow that, right? So with this code, if the male is checked, the female will be unchecked automatically. Right? So I need to do that for the second checkbox as well. This time I will write male dot is checked equals false. If the female is checked, the male will be unchecked automatically. All right, so let's run it and see it again. All right, so it's working now, and when I check male, the female is unchecked. When I check female, the male is unchecked. Good, good, good. All right, so that's enough for now. We'll take a short break here if you need to, and I'll see you in the next video. All right, hello, everyone. So now, where do we go from here? Checkboxes always lead to radio buttons, so we're going to do radio buttons in this video. So radio buttons are very similar to checkboxes that we did last time, but radio buttons are inside a group, and users can choose one option from the group, right? Radio buttons are separated from checkboxes because of this feature. So, for example, you can use radio buttons on a test application, right? Users can only choose one option from the answers. You can also use radio buttons to take some information from the user, just like checkboxes. But in the checkbox, there is two options, right? For one checkbox, checked or unchecked. But when you use a radio button, the user has to choose one option from the group. Also, one option is chosen by default. Okay? So that's enough information. We've all used radio buttons, but now let's go to Android Studio and practice what to do with them. So for this lesson, I have now created a new project, and the name of this project is Radio Buttons. You can also create a new project or continue from the previous one. It's up to you. But what I do want to do is show you the sample application that we're going to be doing so you know where we're going. All right. So as you can see here, there are 3 radio buttons on the screen. The names of the radio buttons are green, yellow, red. Now there's also a button here. The user will select one of the options and then click on the button. All right. So the background color of the application will change depending. All right. Let's do it. Now, if you notice, our main layout is constraint layout, but I'm going to use a linear layout in this lesson. So my goal here is to learn how to use both the constraint layout and the linear layout. And you'll just know it backwards and forwards, all right? So remembering, of course, that we've used the constraint layout in the previous lesson, I'm now going to change to the linear layout in this lesson, all right? So let's go ahead and open up the XML side and change the constraint layout to linear layout. I just write linear layout here. Now, also, I'm sure you remember that we had to specify the orientation while we were working with the linear layout. So that means I'm going to just make the orientation property vertical. And let's go ahead and create the application design completely using XML code. I think you're ready. Come on. As an Android developer, you should know how to use XML code. Okay. So first of all, since I'm going to add the components into this linear layout, we should also close the tag of the linear layout as follows. So I'm deleting the greater than and slash right here. Now I'll close the tag by pressing the shift and less than keys on the keyboard same time. All right. So now I can add the component that I want to into the linear layout. So what we'll do first is change the background color of the linear layout. Now, you do remember, right, that we were using the background property for this? So when we start typing background here, the code editor does offer us some options. Cool. So from here, I select Android background feature, press enter. Now I can choose a color, and you can write the code of the color that you want, or just add it directly with a hashtag at the beginning. You could also choose any of the colors defined in Android. For this, I'll just type Android in here and select the @Android option here. And there you see the code editor offers us a host of colors. So here, just choose any color you want. I'm going to choose color Hollow Blue Dark. And as you can see, the background color of the design area immediately changes. All right, so now let's add some of the other components into the design area. So first, I'm going to add radio buttons because that's what we're doing. Now, of course, we should not add radio buttons directly to the design area. Remember? First, I need to add a radio group. Then I will add the radio buttons to this radio group. I'll open up a new tag, pressing the less than key on the keyboard. Then I write radio group in here and press enter. I'll make the width and the height of the radio group wrap content. Now I'm going to close the tag of the radio group and add the radio buttons inside. I press shift and smaller than keys on the keyboard. And I need to create a new tag for the radio button. So I'll press the less than key and type radio button. The width and the height of the radio button can be wrap content. Also, let's change the text of the first radio button. So I'll type text, select the Android text option. Let the text of the first radio button be green. All right, let's also change the text size. And here I'll just type size, select the Android text size feature. And the text size can be 20. Let's change the text color. I'll type color and select Android text color property. All right, so here you can specify any color you want, of course. I'm just going to choose white, defined in the color.xml file. Now, when we type white in here, we're presented with the color white option. So I'll choose it. And as you can see, the text color of the radio button has changed immediately. All right, so now, yes, we have created the first radio button. Yay. But we're in a group, so we've got to create 2 more radio buttons. But all I need to do is copy and paste the code here twice, right? Because radio buttons are going to have all these similar properties. So as you can see, we have now 3 radio buttons in the design area. Of course, there is one thing left to do. I got to change their text. So the text of the second radio button is going to be yellow. Text of the third radio button will be red. All right, so there's our radio buttons. Now we've got to create a button. Okay. Of course, we've got to create this button outside of the radio group and inside of our linear layout. So for that, I will open a new tag and write button. And the width and the height of the button can be wrap content. So now let's change some of the properties of the button. For example, we can make the text size 20, and we can use the Android text size feature. And we'll change the text. For example, we can write change background in the text of the button. And now if you pay attention to this, all the letters are written in capitals on the design area. And you can also change that if you want. So we use the text all caps property for this. So if you set this property to false, it's going to appear in the design area the same way that you specify the text of the button. All right. Finally, let's change the background color of the button. Now, if you remember, we use the background tint property for the background color of the button. For the background color of the button, let's just write a color code this time. Now, again, you got to be familiar with this usage, right? So for this, I'll just write the code of the color that I want to add after this hashtag sign. For example, I'm writing the following code in red tones. Of course, you can get these codes just by doing a simple search in your favorite search engine to scour the World Wide Web. You don't really need to memorize these codes, but when you use them enough, you tend to remember what your favorites are. Anyway, we've created our components. Let's now arrange the location of the components a little bit better in the design area. So I will now make the gravity property of the linear layout center horizontal. That way, all the components will be centered on the horizontal plane, right? Now let's move the radio button component down a little bit. For this, I can set the margin top value to, let's say, 75. Also want some distance between the radio buttons themselves. So for this, I can use the margin top feature. I set the margin top value to 5 for the first button. And now I can just copy this line of code and I can paste it into the other two radio buttons. And there you see that there's some distance between the radio buttons. All right, so that's cool. Now, finally, I'm going to make a margin top feature of the button 50 dp. Yeah, so there you can see the design looks a little nicer. But in fact, yeah, I'm just finished with the design entirely, but I do want to add one more feature. So you can make any of the radio buttons selected by default. All right, for example, let's make the first radio button selected by default, and for that, we can just use the checked property. So here, if you set this property to true, the radio button will be selected by default. Okay, so finally, let's define the IDs of the components. And I will first define the ID of the linear layout. So here I write ID, select the Android ID feature, then select @+ID/, and press enter. Now we can select the ID. The ID of the linear layout can be linear layout. And now let's define the ID of the other components. The ID of the first radio button can be radio button green. The ID of the second radio button could be radio button yellow. ID of the third radio button can also be radio button red. All right. So finally, we'll determine the ID of the button. And we'll let the ID of the button be button change. All right, my friends. Yeah, that completely finishes this design. So as you can see, you can design your application using XML codes without even knowing it, right? That's cool. Good job. You can do the same things we did here using the attribute section. But anyway, now let's open the main activity.kt file and begin coding. All right, so first of all, what do we need to do? Define the components. So I will define the linear layout. Now, by the way, I got to mention this. If you remember, we did not specify the IDs of the layouts in our previous lessons. We did not define the layouts here. This is because we never use layouts while coding, right? So in other words, if you are not going to use a component in the design field while coding, you do not need to define it here. But since we will change the background color of the layout by using the radio buttons in this lesson, we have given the linear layout an ID, and we need to define it here. Follow? Yeah. So let's start defining the layout now. I'll write late init var. I'll write linear layout as the variable name. Then after the colon, I'll write linear layout. Now I will define the radio buttons. Late init var. The name can be green for the first radio button after the colon. I'll write radio button. And for the second radio button, I'll write late init var yellow colon radio button. Last radio button, I'll write late init var red colon radio button. All right. Now, lastly, we got to define the button. So I'll write late init var. The name of the button can be change. After the colon, I'll write button. Cool. So after all that, I need to define IDs for these variables in the onCreate function. So I'm going to write linear layout equals find view by ID, r.id.linear layout. And here, green equals find view by ID, r.id.radio button green. For yellow, yellow equals find view by ID, r.id.radio button yellow. And for the red, red equals find view by ID, r.id.radio button red. Now we got the button, so change equals find view by ID, r.id.button change. All right, so we've defined the components. But what do we want to do after that? Well, let's see. When the user chooses a color and clicks a button, the color of the layout's got to change. So to do this, I need to add a click listener to the button change. And that I will write here, change.setOnClickListener. And then inside the curly braces, I will write my conditions. All right? If the green radio button is checked, it means that if the user selects the green option, we should make the background color of the linear layout green. Right? So I will write inside the brackets linear layout.set background color, and inside the parenthesis, I'll write color.green. So that's my first condition. So if the user chooses the green radio button, the background color will turn green. All right, so after that, I need to write the second condition. Else if the yellow dot is checked, layout.set background color, color.yellow. And likewise for the third condition, else if the red dot is checked, layout.set background color, color.red. So far, so good. Let's run it and see if it's working or not. So the application opens. When the green radio button is selected and click the change background color, the background color changes to green. Whew. Let me choose yellow. Background color is yellow. So let me choose red and click the button. Background color turns red. Wow. Okay, cool. So you should be able to see that I can choose only one option with these radio buttons. Yeah? Excellent. So I don't know about you, but I think radio buttons make sense, pretty easy. So that's enough for now. We're going to get to something else in the next video. So I'll see you then. All right, hello everyone. We're going to work on a toggle button in this video. So the toggle button pretty much gives two options to the user. It's basically on and off, right? Now you define what needs to be done when the user takes it to the on position, but it is fairly easy to use. So why don't we just go to Android Studio and practice with it. Now I have created a new project for this lesson. And the name of this project is Toggle Button, but you can always create a new project or continue with radio buttons or whatever your previous project is called. So why don't we just first have a look at this sample application that we're going to be doing. It gives you an idea where we're going to go. So as you can see, there is one image view, one text view, one toggle button. Also, the text of the toggle button is hide image. All right. So when we click on the toggle button, the image disappears. The text of the text view changes to the image is invisible. Now also the text of the toggle button changes to show image. So if I click on the toggle button again, the image comes back to me. Just like that, the text of the text view changes to the image is visible, and also the text of the toggle button changes to hide image. All right, so that's what it looks like. Let's get started. Now, first off, of course, you're going to need to add an image. So I'm going to add the image that I'm going to use in my project to the drawable folder. I copy the image to add, then right-click on the drawable folder and select the paste option. And from here, of course, you must select the drawable folder. And I'm not going to change the name of the picture. So I'll just add the picture to the drawable folder by pressing the OK button. All right, so now let's design the application. So first I'm going to change the background color of the constraint layout. And again, I want to choose the hollow blue dark color that I've always chosen because I like it. You can choose any color that you want. Okay, so now I can add an image view component to the design area. I'll just drag it from the palette and drop it right here. So now I can select an image from this window. So I select the picture that I just added and press the OK button. Of course, the size of the picture was so large that it took up the entire screen. So I'm going to need to make the width of the image view component 300. I'm also going to make the height 200. All right, so now let's add a text view component. I'll make the width of the text view component 300, and I'm going to make the height 50. Okay, so now let's change the text. So I'm going to type in, the image is visible. And I'll set the text size to 20. Make the text color black. And I'm going to change the background color to white. All right, so let's center the text in the text view component. I will use the gravity feature for this. I'm setting the gravity value to the center. Now we can add a toggle button. All right, so you can see the toggle button, and it's under the button section, right? So I'm just going to drag a toggle button and drop it under text view. All right, so the toggle button also takes two different options. I'll define what will happen when it takes the on position, and also what's going to happen when it takes the off position. But before we do all that, we can change the text of the toggle button. Now, where do you do that? Well, you know that we've changed all of the text of the buttons that we've done from text attributes, but we're not going to do this for the toggle button. There's an other text attribute. It is the text off, the text on property. All right, so we're going to define a text in the text off section so that when the position of the toggle button is off, text off. Also, we'll define the text when the position of the toggle button is on, and I'm going to write hide image for the text off and the show image for the text on. All right. Now, since our main layout is this constraint layout, I've got to determine the constraint values of the components. So first, I will center all three components horizontally. After selecting the image view component, I'll press the Control key on the keyboard and select the text view and toggle button components. All right. So now that I've selected all the components, I'll now right-click and select the Center Horizontally option. Very cool. So there, we've now centered all of the components horizontally. So now we got to determine the constraint values of the components in the vertical plane. So I'll set the top constraint value of image view to 50. Set the top constraint value of the text view to 20. And finally, I'll set the top constraint value of the toggle button to 30. Okay, cool. So we've now completed the design. Now I got to determine the IDs of the components, right? So let's make the ID of the image view component be image. And we'll let the ID of the text view component be result. I'm not going to change the ID of the toggle button. All right. So now let's open up mainActivity.kt file so that we can start coding. Very cool. So first of all, I'll need to define the components. So I write late init var image : image view. On the next line, I write late init var result : text view. And lastly, I'll come in here and write late init var toggle button : toggle button. And of course, you can give it another name if you want. But after that, I'll define their IDs inside the onCreate function. I'll write here, toggle button equals find view by ID, and inside the parenthesis, r.id.toggle button. For the image view, image equals find view by ID, r.id.image. And for the text view, result equals find view by ID, r.id.result. Now we can do operations on the toggle button. So I'll need to add a listener. Now normally I would add the click listener, but for the toggle button, we need to add the checked change listener. All right, so I'll write here toggle button dot set on checked change listener. And as you can see, the code editor offers us some options. So from here, we can select the option with the curly brackets next to it. So choosing this creates two parameters. As you can see, the first parameter is the parameter from the compound button class. The second parameter is a Boolean parameter. So that is when the position of the toggle button changes, this change is automatically detected and returns true or false. All right? So here we're going to get this returned value from the parameter, and we'll change the name of this parameter for better understanding. So I'll just type is checked here. So now when the checked position of the button is changed, the listener will detect this change and apply the codes that I wrote here. All right? And it's going to take two positions, checked and unchecked. So that means that when the toggle button is on, it takes checked, and toggle button's off, it's going to take unchecked. So here I'm going to write if is checked, and inside the brackets, I will hide the image. All right, so how do I do that? I just write in here image.visibility equals view.invisible. And then also I'll want to change the text of the text view. So I'll write here result.text equals the image is invisible. After that, I will write the else condition. And that means when the toggle button takes the off position again, All right, I will write here image.visibility equals view.visible. Also, I've got to change the text of the text view again, and I'll write result.text equals the image is visible. Whew. Okay, so let's run the app, see if it works. So now when the application opens, you see the toggle button. The text is hide image. When I click on the toggle button, the image is hidden and the text of the text view changes. Cool. So also the text of the toggle button changes, right? So when I click it again, the image is shown, text of the text view changes again, and so does the text of the toggle button, changes back to hide image. All right, so it's kind of easy, right? I think it's enough for now, so we'll take a short break, and I'll see you in the next video. Well, hello, everyone. So we're going to talk about Spinner in this video. So Spinner is an Android component that we use in Android application development. Spinner opens a list, and then users can choose an item from the list. And when the user selects an item from the list, certain operations can start up with this selection. So why don't we just go to Android Studio and learn how it works. Now I've created a new project for this lesson. Name of this project is Spinner. You could also create a new project or continue with the previous one. It's up to you. Now we're going to do an example in this video. So the example project is going to go like this. So there's a list of countries, right? So when the user selects a country from the list, the country name will be written on the text view. For example, if I select Germany, on the text view, it's going to write Germany. So if I select the Netherlands, on the text view, you're going to see Netherlands, right? So that's pretty much how a spinner works. Why don't we see the rest of it as we do the application? All right, so first we're going to add a text view component. I'll make the width of the text view component 300 dp. Also going to make the height 50. Now let's set the text size to 20. And we'll change the background color. And why don't we make the text color white? All right, so finally, let's center the text in the text view component. And I want to use the gravity property for this, so I'll set the gravity value to center. Yeah, so we can add a spinner to the design area. So spinner is under the containers section. Now also, I'm going to change the width of the spinner to wrap content. So now we have a text view and a spinner. And we will need to give an ID to the components. So for the spinner, I'm just going to write spinner country. And for the text view, I will write result. And since our main layout is the constraint layout, I've got to determine the constraint values of the components. So first, I'm going to center all components horizontally. And after selecting the text view component, I'll just press the control key on the keyboard and select spinner. So now I can right click with my mouse and select the center horizontally option. And look at that. As you can see, that centers all the components horizontally. So now let's determine the constraint values of the components in the vertical plane. Now I set the top constraint value of the text view to 100, and I'll set the top constraint value of the spinner component to 20. So after that, I need to fill in the spinner. So to fill in this spinner, I need to create an array. Now I'm going to do this under the values folder in the strings XML file. So I'll open up this string XML file. And as you can see, one string is created here by default. Name of the string is app name. And its value is the application name, namely spinner. So now we will create an array of the type string here. For this, I need to open up a new tag and choose the string array option. And we have to give this array a name, and I'll write in countries. So when I press the shift and less than keys on the keyboard, it closes the tag. And we need to do that because we're going to add the country names into this array. So each element that we add is called an item, right? So I'm going to open up a new tag here. And this time I will choose the item option. And then I'll close this tag too. Now we can write the country names that we want to appear in the spinner between the item tag. So the first country, I'm just going to make it England. Second, Netherlands. Third, Belgium. Fourth, Germany. Fifth, Finland. All right, so now we've got 5 items inside the countries array. All right, so the spinner's ready to go. The array is also ready to go. So let's go to the Kotlin side. First thing I need to do is define the components. I will write in here late init var spinner colon spinner. And also I will define the text view. Late init var result colon text view. Okay, now inside the onCreate function, I have to match these variables to their IDs. Spinner equals find view by ID r.id.spinner country. Result equals find view by ID r.id.result. Now, let me just take a moment to explain a pretty important topic here. So we've got a spinner and an array. To transfer information from the array to the spinner, I'm going to need to create an adapter. So in this case, what is an adapter? So let me just show you with a picture, because it's very important. I want you to have a look at this in detail. We will use the adapter in some of the other components as well. So now we're going to use this adapter for the spinner, but we'll also use it for the list view and the grid view for some of the next videos. So we will call the adapter, and then what makes a connection between a data set and a view. In this example, the data set is array list and the view is spinner. Then we need to create an adapter between the array list and spinner. And I do this in the main activity using Kotlin code. All right, so in the onCreate function, I will write var array adapter equals. After the equal sign, I will write array adapter dot create from resources. The create from resource function allows you to create an array adapter from the string array. All right, so I need to define 3 parameters in parentheses. First is context. I'll write this here. So that means this adapter will work in this class. Also, you can write application context or this at main activity for the context as well. So the second parameter is array ID. I'll write r.array.countries. I defined array ID to the adapter. Okay, so the third argument for this method is a layout resource that defines how the selected choice appears in the spinner control. So I'll write android.r.layout.simple spinner item. All right, so the simple spinner item layout is provided by the platform and is the default layout that you should choose unless you'd really like to define your own layout for the spinner's appearance, but Just you got to learn about it first, right? So now I'm going to need to specify the drop-down layout. So I'm going to write arrayAdapter.set drop-down view resource. Okay, so inside the parentheses, Android.r.layout.simple-spinner drop-down item. So the simple spinner drop-down item is another standard layout defined by the platform. All right, so that makes the adapter ready. I just now need to assign this adapter to the spinner. So how can I do this? What if I write spinner.adapter equals arrayAdapter? So then these codes will fill in the spinner with a country's array. All right, so let's just check, see if we've done it so far so good. The application opens, and you can see the spinner is filled in with country names. So let's just go over what we've done here. Do you know what we've done until now? We've created a spinner and a data set, and then we connected these spinner and data sets using the arrayAdapter. So then after all of that, we need to do just one more thing. So when the user selects a country from the spinner, the name of the country should be written in the text view. All right. So that's where we need to continue. And to do that, I'll add a listener to the spinner. But first, we need to implement the adapter view.onItemSelectedListener. And this is an interface that gets added to the main activity class. All right, so that way, when we implement this interface, two functions that we will control the select process was going to be overwritten. All right, so we'll just do it now. I'll put in a comma right after the app compat activity and write adapter view after the dot. The code editor proposes the interface that we will implement. So I select the onItemSelectedListener and press enter. And you can see that Android Studio gives a warning because there are two functions that we need to implement. Well, I'll just hover the cursor over main activity, and from there I select the implement members option. Now you can see that there are two functions here, right? I select both functions and press the OK button. And as you can see, there are now two functions outside of the onCreate method. Also, the warnings are gone, so we can delete the to-do statement inside these methods. All right, so let's examine these two functions. First one is onItemSelected. Another one is onNothingSelected. So I'm going to write my codes here. When the user selects an item from the spinner, this method will work. So now let's look at the parameters here. The first parameter is the parameter of the adapter view class. Also, I should mention that the parameter names here may be different for you, but it doesn't matter. You can change these parameter names if you want to. You can even change the whole thing. I just write parent instead of P0. All right. Second parameter is an object of the view class. So we can also write a view here. The most important parameter is the third parameter because this parameter gives the index number of the clicked item in the array. So using this index number, we can determine which item was clicked. So that's why I'm going to write position here. All right, so the ID of the item that was clicked in the last parameter, we can also write ID here. Now, let's print the name of the country that was clicked into the text view component. So I'll just write in here result.text equals parent.getItemAtPosition. Inside the parentheses, I write position. Finally, I write .toString. So what's this code going to do? It's going to take the text of the item in the selected position, and after that, I will assign this text to the text of the text view. Now, of course, you may notice there is a warning here, and that's because a parameter in an adapter view class can return null. So here we need to prevent my app from crashing in the case of returning null, and we can do this in two different ways. First is to put a double exclamation mark here. All right, so this statement guarantees that the parent object will never be null. Now, the second method is to create an if statement here. So if the parent is not equal to null, we should print the selected item in the text view component. All right? Yeah, now there's one more thing to do. Within the onCreate method, we must write spinner dot on item selected listener equals this, just below the line where we define the spinner. This keyword here is an instance of the interface that we're implementing. Follow? So in other words, when any item in the spinner is clicked, the operations that we described is just going to take place. All right, so let's run it and look at it again. So the application opens when I select Netherlands. In text view, you will see Netherlands. When I select Germany, it's going to write Germany in the text view. Yeah, so whichever item that I select from here, the name of the item is going to be written in the text view. All right, so that's what Spinner is like. So I think that's enough for this video. I'll see you in the next video.